Very good. Now because I heard two beeps on the mute button. Okay. Good morning, everyone. Welcome to day 2 of the training. Before we start discussing today's topic and today's agenda, let me clarify one more time this for everybody. You're going to get the recording for the session of today. You already have the recording already for the recording of yesterday, right? In the box folder that you see on this slide here. Raffaella will also post probably the link in the Q&A chat window so that you can copy and paste. You will find in the box folder also the slides that were used yesterday and also the slides that we're going to present today in PDF version, right? So you can download them and follow that, okay? So again, recording is there for yesterday. It will be there from today once we're done. And the slides of today are already in the box folder. With this, let me share my PowerPoint and let's start with today's topics. So welcome everybody, good morning, good afternoon. My name is Max Erdica, I'm a principal engineer, part of the intent-based networking group or data center business unit. I'm here with my partner in crime, Joe Ezerski, that you already met yesterday. Joe is the man with no title because he doesn't need a title. The name is enough to qualify him, right? And so what we're going to do today, we are going to take over where things were left yesterday. If you remember yesterday, Chris and Joe walk you through the bring up of an ACI fabric from zero till the point where you were able to communicate between endpoints, part of different EPGs, and east-west, and also north-south. What we're going to do today, we are actually building on top of that, and we're going to extend the connectivity across different pods and different fabrics and sites. So we will clarify what we mean with pods, what we mean with site, what we mean with this architecture like multi-pod and multi-site that allow to extend connectivity and security policies across different ACI networks. Okay, so that's the overall goal of today. It will be like yesterday, a mix between lecture that I will drive and lab stuff that Joe will drive. We want to favor the lab, but we need to give you some lecture because I'm not sure how much knowledge there is in your base, right, for what concerns multi-pod and multi-site. So I will give you some basic information so that you are able to better appreciate what Joe will show you in the lab, okay? So first slide is basically an overall overview or recap of the ACI journey that we did from the beginning to today so that you can appreciate all the architecture that we deliver as part of this ACI Anywhere umbrella, okay? So if you look here, what ACI was at the beginning, which is what you saw yesterday, was basically a single pod fabric where all the leaf and spine were fully meshed, connected with each other, and you were managing all these leaf and spine from the same EPIC controller cluster. And usually this leaf and spine topology was deployed in a single data center location, right, and represented a single network. Now, right after this, customers started saying, well, okay, but I don't really have a single room, a single building, a single data center. I have scenarios where I want to interconnect ACI networks that because of physical constraints or geographical location, they are not, they don't allow to create a full mesh. So how do I manage different ACI network from the same EPIC domain controller so that I can still benefit from the operational simplicity of having a controller that manage my entire fabric as a single giant switch, right? And this basically gave birth to what we call like the ACI multipod fabric. We will talk a little bit more about ACI multipod soon, but I want you to understand that multipod is still a single fabric. It's still a single EPIC domain. The main difference between a single pod fabric and a multipod fabric is the network full domain isolation characteristic that we can provide between the different pods. So each pod represents like, the single pod that we supported at the beginning, And we are able to interconnect these different pods and manage them in a cohesive way so that you can basically provision configuration and do day 2 operation the same way that you would do with a single pod, only now with pods that could be geographically distributed or deployed in different rooms or buildings of the same physical location. Okay, so the key point of multipod is operationally simple, like a single pod, but more scalable and more resilient. Okay, and we'll touch upon this point again later in the introduction of multipod specifically. So, but multipod is still a single fabric, so it's still a single epic domain, which means, as you saw yesterday, it's very easy to configure stuff, but it's also very easy to destroy stuff. Remember, Chris showed you how you could delete an entire tenant in one shot, right? Then you can push it back, sure, but you can also delete an entire tenant, and when you delete your entire tenant will be gone across all the pods that are managed by the same epic controller cluster, okay? And this is why it's acceptable when these pods are different rooms of the same data center or even data center in close proximity that are used for typical active-active use cases. It may not be acceptable for scenarios where you have, for example, disaster recovery between data centers, right? If you have a main production data center and disaster recovery site, and making a change on the epic in the production data center changes or impact also the disaster recovery site, you don't have a disaster recovery site, right? You have a single change domain that glue the two locations, which is the reason why we didn't stop with multipod as an architecture to interconnect different networks, but we went ahead and we deploy ACI multi-site. We will see that from a technical perspective and from the type of connectivity also that you can establish across, multipod and multi-site have similarities, but the main difference is that in multi-site, each of these ACI network, each of these gray box with the switches in it, represent a separate fabric, a separate epic domain. Okay, and obviously, and I will harp on it soon, each of these fabric that you see in that multi-site picture could actually be deployed as a single pod fabric or as a multi-pod fabric. And really, the message that I want you to take home when we finish this session is that really the power of this architecture is to combine them, right? So building multi-pod plus multi-site will give you all the ammunitions that allow you to cover all the possible use cases that you may have. Okay, it's not one versus the other, it's one plus the other. It's a typical case of 1 + 1 = 3, okay? And we will talk about multi-site more in detail in the rest of the presentation as well. We didn't even stop with multi-site because multi-pod and multi-site were two architecture that allows you to interconnect ACI network where each ACI network is built with a leaf and spine topology. But there are scenarios and use cases where you may need to extend ACI connectivity and policies to part of the network where you don't have the justification to build an entire leaf spine topology. Think about a satellite data center. Think about location where you have only one rack of servers or two racks of servers that need to be connected to the main ACI fabric. For that, we deliver an architectural option called ACI Remote Leaf. And this remote leaf comes in two flavors. There is a physical flavor, which essentially means you take a pair of Nexus 9000 physical switches, you connect them in that remote location where you have a limited amount of services that you want to connect to the network, and you operate that pair of remote leaf switches as if they were connected to the local spines. Okay, from an operational perspective, provisioning, day 2, etc., they are absolutely operated as if they were local leaf, but they are remotely located and connected to the spine, not with direct link, but through a generic IP-WAN infrastructure. Okay, that's what concerns the remote leaf. So remote leaf, they join essentially the same fabric where the main spine are connected, and they are managed. Their configuration is managed by the same epic domain that manage the main pod where the remote leaf connect to. Right. Obviously, we support integration of remote leaf with single pod fabric, with multi-pod fabric, And we will send you a link. There is actually a white paper that talks about remote physical leaf and all the deployment consideration around remote leaf. But the idea is remote leaf allows you to extend connectivity and policy to edge location where you don't want to build an entire pod, right? Otherwise, you would have multi-pod, okay? There is also a virtual version, if you want, of this remote leaf that takes the name of vPod that allows essentially to create, to configure or to provision a virtual ACI leaf functionality directly on the hypervisor, okay? So that you don't even need to deploy a physical hardware, Nexus 9000 hardware, to allow the VMs that are connected in that hypervisor access to the ACI environment, okay? That virtual leaf architectural option is usually called vPod, and there is a white paper. If you search for ACI vPod, the virtual pod, you will find also a white paper that talks about what vPod is and how to deploy. We are not covering remote leaf and vPod in this presentation because we focus on multi-pod and multi-site. And the last step of ACI Anywhere, all these three architecture, multi-pod, multi-site, and remote leaf, allows essentially to interconnect on-prem locations, right? Data centers, rooms, bare metal cloud offers like IBM has when we talk about vPod. What was missing was the capability of extending the connectivity and the policy to the public cloud space. And this is what Cloud ACI actually brought to the picture. And we'll talk about Cloud ACI. I believe that's part of tomorrow. Domenico will come and discuss this in greater detail. The important thing and the point that you want to take for now is the fact that from an architectural perspective, Cloud ACI looks very similar to ACI multi-site. There is a central policy manager, which is our multi-site orchestrator, that sits on top of a set of sites, right? The only difference between multi-site and Cloud ACI is that in multi-site, all the sites that are managed by the multi-site orchestrator are physical on-prem ACI fabrics, right? With physical leaf and physical spines. With Cloud ACI, some of these sites could actually be public cloud locations, so AWS and AWS VPC, and Azure VPC, or a Google Cloud VPC. Okay? So this is the entire journey. Now we'll focus on multi-pod and multi-site. And when I go and talk about this, the first question that comes up is, okay, multi-pod or multi-site, what should I do, right? That's usually the question. Which architecture is the right one for me? And the answer for me is very simple, and I already gave it to you before, both, right? It's a power of combining the two architecture rather than picking one versus the other. Why do I say both? Because to understand this, we bring in some concepts that you may be familiar with in the AWS world. There are the concept of availability zones and regions. Okay, so when you go to the public cloud, you need to deploy your VPC to host your application. You normally deploy your VPC inside an AWS region, okay? And the endpoints and the subnets that you deploy in that VPC, they're usually deployed across different availability zones. These availability zones roughly map to different physical data centers with different power, different compute power, electric power, right? So that allows a more resilient deployment of the application, because if something happens to availability zone 1, you still have an availability zone 2 still up and running inside the same region, and your VPC and your VPC capabilities and application hosted in VPC remains up and running, okay? We want to basically follow the same approach also with our multi-pod plus multi-site architecture. So we want to basically compare how I build a similar concept of availability zone and regions using the ACI architecture that I just mentioned. By the way, this concept here is that I just explained is in the context of AWS. The exact same consideration, pretty much identical, apply for other public cloud options like Azure or Google Cloud. Okay? They all have this concept of availability zones and regions. And so when we go to now our ACI architecture, we can say that each pod that I create can be equated to an availability zone. Why? Because a pod could be a physical data center with my leaf and spine topology, okay? And different pods, different availability zones can be grouped together to become a common application policy change domain, right? What basically in AWS, in Azure, in the public cloud means a region. And now you understand that the pod is the availability zone. All the pods that are under the control of the same Epic controller cluster becomes a region. And so multi-pod allows essentially to build the equivalent of a region. When you deploy an application, right, that application, the component of the same application may be deployed across different availability zones, different pods, because all these pods are really operated as if they were a single logical entities. I don't care if my VM is in pod 1, pod 2, or pod 3. I can use dynamic mechanism like vSphere DRS, HA, fault tolerance to move my VMs wherever I need. Okay? For me, it's a single logical set of resources. That gives me more resiliency than a single pod, but it doesn't change the way that I operate it, right? So multi-pod is a perfect architecture to build this region concept and allow them to deploy application however I want across the different availability zones / pods that exist in the region. Then when I need to build another region for another purpose, for example, for disaster recovery purpose, I could use another multi-pod fabric or a single pod fabric, and then introduce the ACI multi-site orchestrator and the ACI multi-site architecture as a way to interconnect my regions, right? So with this view, the multi-site orchestrator really becomes a region, an inter-region orchestrator, right? A multi-region orchestrator. Some people suggested, why don't you call it MRO, right? Multi-region orchestrator. But you get the point, right? With multi-site, you can have, here I'm showing layer 3 inter-region. In reality, we will see, we can also stand layer 2 connectivity with multi-site between fabrics that are part of the same multi-site domain. But really, what you want to do, if you have a layer 2 connectivity requirement or a lot of layer 2 connectivity requirements, that's usually a hint that multi-pod is the right architecture for you, because it means you really operate all these data centers as a single, logical entity. If instead multi-site, I have some cough, multi-site allows you to control more the connectivity that you establish between these regions, and you can, if you want, you can actually limit. Sorry, 1 second. Okay, I'm back. I'm still alive. You can limit connectivity only to layer 3 if you want to do so. Okay? So this is high level, the positioning, how this architecture can be deployed in conjunction to address the different use cases. Multi-pod, active-active, traditional active-active, multi-site, more loosely coupled data center deployment. Now, I know perfectly that we gave you functionalities and tools to use multi-site and deploy to cover use cases that are more multi-pod typical, right? And so what you see here is that with multi-site, actually, we can establish not only layer 3 connectivity between the sites or the fabrics that are part of the same multi-site domain, but we can also stand layer 2. And we can extend layer 2 in a smart way, which means option 2 in the slide, which is without extending the flooding, which is the bad part usually associated to the layer 2 extension, and still do remotion and still do IP mobility, right? So multi-site gives you something more than a traditional layer 2 DCI technology. But I can also, if needed, extend layer 2 with flooding, right? If I need to support some application clustering that requires flooding. So from a connectivity perspective, you can do everything you want with multi-site in terms of layer 2 as well. Now, the fact that you could doesn't, as I always say, doesn't necessarily mean that you should, right? And to me, to build a very resilient and hierarchical design, the goal is really to put together multi-pod and multi-site, as I showed you before, right? Where multi-pod is really the glue that allows you to extend your layer 2 domain wherever you want, and layer 3 gives you a more control inter-fabric communication pattern, okay? with this, hopefully, at least at very high level, 10,000 feet overview, you have an understanding of the positioning of the two architecture, right? They are not there. Multi-site didn't come to remove or obsolete multipod. It came to complement multipod, okay? And majority of customers we actually work with and I work with on a weekly basis, they are doing some sort of combination of the two architectures together. Okay. Now with this, we're going to actually start giving you a little bit more points or description about multipod, and then we will see how we, in the lab, we can start from the single pod fabric that was built yesterday and extend the single pod fabric to multipod to give you the same user experience, the same easiness of deploying policies, right, which make essentially multipod the ideal architecture for active-active data center deployments. Okay, and so what multipod is essentially this, the capability of taking these different pods, these different availability zones, glue them together through an external network that we call the interpod network, and manage them from a single EPIC controller cluster. And that EPIC controller cluster, for resiliency purposes, should be also deployed across pods, right? So it makes total sense to put some EPIC clusters in pod 1, some in pod 2, some in pod 3, depending how many pods you have and how many leaves you have. The point is, it still represents a single cluster. You could, in theory, have all your EPIC nodes in pod 1 and manage the other pods without any locally connected EPIC cluster. I wouldn't do it for a simple resilient discussion, okay? And so in terms of functionality, we use VXLAN for communication between endpoints that belongs to the different pods to basically completely abstract the physical location where the endpoint is connected. Two VMs can communicate with each other, or a VM and a bare metal host, or a VM and a container. They can communicate with each other. Is there a question? Okay. They can communicate with each other at layer 2 or a layer 3 with a given security policy, no matter if they are connected to the same switch in the same pod or to two switches that are deployed across pods that can go up to 50 milliseconds RTT, right? VXLAN, the use of the data plane across the pods, across the interpod network, is what allows to basically provide that abstraction and bring the network, communicate the network and policy information end to end. So allows to have a consistent policy and a consistent connectivity partners no matter where the endpoints are located. In order to know where the endpoints are connected so that we can build this VXLAN tunnel pod to pod, we have a control plane and PBGP VPN that runs spine to spine and allows to exchange reachability information. Every time I connect an endpoint in a pod, the leaf where the endpoint is connected will discover the MAC address and IP address of that endpoint, will communicate that information to the spines. They will put it in the COOP database of the spine, and the spine of that pod will then send an EVPN update to the other pods part of the same fabric to basically give the same information and the same view or where the endpoint is connected to everybody, right? So all the spines are in sync, and they sync the information using that EVPN control plane. But the good news is that if an endpoint were to move 1,000 times between leaves of pod 1, I wouldn't need to send a single control plane updates to the other pods because it still remains in the context of pod 1, right? That's what makes also the entire architecture more resilient and more stable. It's much less control plane activities needed to update the location of the endpoint as long as the endpoint remains inside the original pod, okay? Obviously, if I move across pods, then I need to announce to everybody else, hey, this guy used to be in pod 1, now is reachable via pod 2, okay? So VXLAN data plane, EVPN control plane are the two main functional components that allow multipod to work and allow multipod to look like if it was a single logical data center spread across different locations, okay? Most common use cases inside the data center, customers that have already a cabling plant, and this is a real use case that you see on this slide, a 3-tier cable plant, and they need to adapt that 3-tier cable plant to a two-tiered network, which is leaf and spine topology, right? So what they usually do, instead of building a two-tier leaf and spine, they build again a three-tier network, leaf, spine plus interpod network device, and they connect all the switches like that. Okay, so that's a typical use case that also scale more. We will see. I'll show you a slide with the scale information. Allow me to scale up to 500 leaf node inside the same fabric by deploying them across different pods. Okay, the second use case for multipod is a true, as I said, active-active data center deployments where my pod now map to physical data center, maybe in a metro area, or two data center buildings in the same campus, in the same city, and I interconnect them with an IPN network, which is normally dark fiber or DWDM links, okay? And I manage these pods as a single logical active-active data center environment. I can stretch hypervisor clusters across the pods. I can do synchronous replication. I can stretch firewall services, a load balancer, active standby, active-active. Everything you can do in a single pod, pretty much, you can do it across pod of the same multi-pod fabric. Okay? In terms of supported topology, intra-data center or inside the campus of the same data center, normally you would see pod connected by a pair of higher density switches, like modular switches that you see here. Most typically, when the pods are different physical data center, you will have, as I said, a dark fiber DWDM connection. In rare cases, I would say you see a topology like the one that I see on the bottom right, where you have a generic layer 3 network or MPLS backbone interconnecting the different pods. I would say 90%, 95% of the multi-pod deployment, they fall in the first three use cases, right, scenarios, where I have very low latency, high bandwidth, dark fiber, dedicated connection between the pods. The one on the bottom right used to be deployed sometimes when multi-site was not there. Now that we are multi-site, usually the use cases that allows you that requires to interconnect data center connected through a backbone, they're mostly use cases that are more multi-site than multi-pod. Okay. Last point, and then I'll give the ball back to Joe so that he can show you something live and real about multi-pod, is software and hardware support for multi-pod. Multi-pod has been supported from the beginning with all the Nexus 9000 hardware, leaf and spine, so first generation, second generation, there is no limitation. You can do multi-pod with everything. In terms of the number of scalability, number of leaf, the number of leaves that you can deploy across the pods can go from 0, so 2, to up to 500. Actually, we support 500 leaves across pods starting from the release 4.2.4. The number of epic nodes that need to build your epic cluster depends on the number of total leaves you have. And here you have some recommendation on how many nodes to deploy depending on how many leaves you need to support. As I said before, it's always a good idea to distribute the epic nodes across different pods, especially when the pods represent different data centers, because it gives you more resilience, right? Data center 1 goes down. If I lose only one epic node, my cluster majority remains intact, okay? We can also support up to 6 spines per pod, okay? And in terms of number of pods, we are today at 12, so from 3.0.1 release. We haven't had any ask for more than 12 pods in the same multi-pod fabric. If you have, any scale requirement that you see is above the number that you see on this slide, just let us know and we'll take your use case into consideration, right? These are mostly numbers that come from what has been validated internally, right? We want to be sure that when you put something in production, it will work and it will be fully supported. So we need to basically fully validate it internally first. With this, I'm going to stop, pause, and give the ball to Mr. Joe No Title Man so that he can show you how actually you configure multipod in a real lab.
Very good, Max. If you would pass me the ball, please. I'll get right to it.
Absolutely, would be my pleasure. Maybe. Let's see. back the ball to you. I have not passed the ball. Why? Man, here you are. 1 second. I'm suffering. Okay, someone pass it to you. Sorry.
I'm sharing my screen again, so yeah, so dangerous. I tried to shut off my email and everything. So yeah, let's actually get started on this. Let me make it so I can actually get to things. One of the things before we get started, I wanted to mention, because I know yesterday, I showed a lot of screens and CLIs and consoles, and a lot of the text can be quite small on the screen. And I just wanted to remind everybody in WebEx that you can right click in the sharing window, what we're showing, and you can, under the view menu, actually zoom in, so you can see certain things better and scroll around and things like that. If that helps as well, because today's going to be more of that, with sometimes small text and little things that might be hard to see. So I hope that helps. So configuring multipod in my lab. So if you remember yesterday, we set up a single standalone ACI fabric from scratch, right? That is what is represented here as pod number 1, right? We did all that yesterday, right? So that's still there. It's existing. We're gonna build off of it today, but everything we did yesterday is still intact and in place. So things should look familiar. So we don't have to worry about setting up pod number 1. But what we do want to do is bring pod 2 into the mix. We didn't see that yesterday. It's a completely different data center location, and it has its own single spine and leaf. And then we're going to connect those 2 pods together over this device, or this network that Max talked about, called the Interpod Network, or IPN. So you can see it in my lab. I've got 2 devices, one of them front-ending each of the pods. I do want to remind everybody that what you are seeing is just my lab. It is not a good production topology. Clearly, I need 3 APICs, 2 spines everywhere, likely redundant IPN devices in each side, in each pod, all of those things. Just be careful. Don't take my lab as the production blueprint. Follow the white paper that Max mentioned. So just kind of keep that in mind. But once we connect up our 2 pods, it will be my single APIC, or my APIC cluster in the production example, that's going to manage everything, right? So we have different pods, each with their own independent control planes, but a single management plane. That's kind of the summary promise of what multipod does at a very high level. So what we're going to do first is I'm going to show you how I've configured my interpod network, right? My IPN West and my IPN East. And then I'm going to actually take you into the configuration of connecting the spine 201, that's in pod number 1, that we set up yesterday. I'm going to connect it to the IPN. The cable's already there, but I'm going to configure OSPF routing just between the spine and the first IPN device. I've already got routing set up across my IPN. This is just generic layer 3 routed network, nothing special. So I've already got routing set up across the IPN. But over here on the right, pod number 2, right? Those devices have never been configured. They're sitting there fresh out of the box. They have not been registered to the fabric, but we need to discover them, register them, just like we did yesterday, to bring pod 2 into the mix, right? And as Max mentioned, there are some requirements here for the IPN. Mainly we obviously need a higher MTU, because VXLAN is an additional 50 bytes overhead for the data plane. We need OSPF support and some PIM binder support for bump traffic that Max mentioned. So that's what I will do there. So one of the things that I recommend when it comes time for you to deploy your multipod is sit down, plan it out, make decisions about pod numbering, node numbering, but more importantly, your spine interface, the IP addresses you want to use. We also need a few additional addresses that you see here. The data plane TEP IP, which is the fifth column, 1/32 address for each pod, right? That represents sort of one address, sort of front ends that pod. And then we also need a loopback or router ID, and that's just basic routing. Like when I set up OSPF and BGP, I'm going to source from that loopback, so we want to have that chosen and ready ahead of time. You will probably notice that I'm using really funky IP addressing, 111.111. I obviously did that for ease of remembrance in my lab, but clearly you would choose addresses that work for your environment and that likely you own, because I don't own the 11 or the 22 network, but this is my lab, so I can get away with it. Just be careful, because I've seen deployments where people will email me and say, hey, we got multipod working, check it out. And they use the exact same IPs I did, which again, if it's a lab, no big deal. But if it's in production, obviously, be smart about the IP addresses that you pick. So I will log into my IPN device, but I included a slide about what my IPN looks like here. What we're looking at here is the running config of this IPN West device. So this interface right here, 1/49.4, that's the configuration that we're looking at here for the most part. So notice I increased my MTU. I mean, it doesn't have to be 9150, but obviously if you're going to go jumbo, why don't you go all the way, right? Then I have a routed subinterface on tagging on VLAN 4. It must be VLAN 4. There is no other VLAN that it can be, but not to worry. It's not a big deal because it's a point-to-point link, right? That VLAN pretty much only lives on that cable, right? So it's not like, you're in any kind of, danger that it's VLAN 4. Obviously, an IP address on the interface. I've set up OSPF. I've set up PIM sparse mode, which is required for the bum traffic that Max talked about. I've set up an IP DHCP relay address. What is this? Why DHCP relay? And what is this 10.0.0.1 address? Well, the answer to the second question first. That is the IP address, the TEP address of my APIC in my pod number 1. Right? Normally in production, you would actually have 3 APICs, and so equivalent, you'd have 3 IP DHCP relay addresses: 10.0.0.1, 10.0.0.2, 10.0.0.3. Those would be your 3 APICs. The reason for that is we need something in place to allow us to identify and register the spines and the leaves on the far side and be able to hand out a TEP address. And we do that dynamically. APIC does that dynamically using DHCP. So we need that DHCP relay. Otherwise, we won't be able to discover the far side spine, right? Because yesterday when we did fabric discovery, everything was like directly connected, LLDP neighbors right across the cable. Now we're going across a wide area network. So we need a way to do that. And that's how we do it. I have a loopback in place. This is going to be for my rendezvous point for PIM. It's a fairly basic multicast configuration, but yeah, have a loopback. And then I've optionally chosen a dedicated VRF. You don't have to. I just, for my lab, because I do a lot of funky things, I created a VRF that I named TN Infra. That's just the name that I picked. And then I've set my PIM, my rendezvous point address to 12.1.1.1. And I've got these group lists here, these multicast ranges. You will need both of them. I won't go into too much detail, but this is sort of a copy paste kind of thing. Obviously, pick your own rendezvous point address. It doesn't have to be 12.1.1.1. And then you can see I've got really basic just OSPF running for this connection between spine in pod 1 and the first IPN device. Okay, so we can see that here. I mean, this is my live device. I just did a show run, and you can see I've got all of that stuff here. I've got an extra line here. You can do QoS across the IPN. That's something we're not going to show today for sake of time, but you obviously could do QoS if you were really starving for bandwidth and you wanted to make sure that certain things were prioritized. So that is my IPN configuration device. Now, I actually am using a Nexus 9000 as my IPN device, but it doesn't have to be Cisco. It can be any vendor's device, right? Meaning any generic layer 3 routed network that has those basic requirements like higher MTU, OSPF, PIM biter, those kinds of things. You have all of those. Let's say you had some old HP 3Com stuff laying around that you wanted to use for your IPN. You can do that if it meets the requirements, right? So that's a choice that you will make. Obviously, Cisco devices work great too. So with that, we don't want books. So back here, what I'm going to do is I'm going to go into my APIC in pod number 1, and we actually have a nice wizard that pretty much takes care of everything, and it's actually quite useful. It wasn't always the greatest wizard, but I have to say over the years we've dramatically improved it where I'm a fan and I recommend it. So I'm going to go and do that. So when I get into the wizard, I'm going to want to have my little cheat sheet handy so that I make the right choices to the questions. So here I am in APIC. There's my tenant Acme from yesterday. I'm going to go into the Fabric tab. And if you remember under Fabric, was it inventory? Or no, I'm sorry, was it? Yeah, I'm sorry, Fabric inventory. Under the little quick start area, we have a couple choices here. Add remote leaf, which we're not doing today, and add pod. So when I click on add pod, well, it's going to give me two choices. The first one is physical multi-pod, and the second one is a virtual pod, which we will not show today. It's something related, but a little bit different. This case, we want to do a full physical multi-pod. So all I have to do to start the wizard is click add pod. And it will bring up a wizard. Now we try to be graceful and gentle in explaining, what are you going to do at each step. And so if you go through and you take the time to read this, which I won't, it's basically saying, well, the first thing we need to do is the spine in your pod 1 connecting to the IPN, and let's get OSPF up and running. And then once we get OSPF up and running and we discover the far side pod, we can bring up MPBGP as a control plane, and then everything is going to work. So you sort of read that, understand that, and click get started. So the first, or actually the second step is IP connectivity. Again, it's saying we need to establish OSPF between spine in pod 1 and IPN device over a point-to-point link. So we already know from my setup yesterday that my single spine in my pod is spine number 201, right? So I knew that, but of course, I'm also making sure because it's in my cheat sheet as well. Sorry about that. So I need an interface and an IP address for this spine. So again, this is where the cheat sheet comes in handy. Interface 1/25 and IP address 202 dot something. So let's actually configure that. 1/25, and we'll paste that. See, it's nice and easy when you've already made your decisions ahead of time. We'll go ahead and click next. That was pretty easy, right? So the next thing is routing protocol. In this case, we're using OSPF on the link between spine and IPN. So you are going to choose your area. In this case, I am using area 0. That's how I configured this guy over here, my IPN device. And it is a regular area, but it can be a stub area or a not so stubby area. But in this case, the regular areas is probably what you want. Interface policy. Well, you remember I had a policy for my ASA firewall yesterday. I think I'm going to create one dedicated for this. Maybe in the future when it comes time to troubleshooting, I want something else. So I'll do I'll call it mpod OSPF Paul. Again, I'm just picking a name that makes sense for me. You will do what works for you. In this case, it is a point-to-point network. In my lab, again, these are choices that I make. You will have to make your own choices, but these are pretty generic. I ignore MTU. I like to advertise the subnet. Don't have to. And I like to use bidirectional forward detection. Again, that's an optional feature that's supported in my IPN. But again, those are just my choices, and I'll make that policy and click submit. You can untick these things use default. So if you want to do something like OSPF authentication, you can. So it can be secure. In my lab, I don't use it, but I wanted you to know that it was possible. And if you untick the column for BGP, because here's OSPF on the left, BGP on the right, there are some things we set for you. And again, if you wanted password, you could as well. But again, it's simple in my lab. So that's all I really need for that step. That's not too hard. I'll go ahead and click next. Now I need to set up some TEP addresses, right? And if you see a box in red, it means you must enter something. So data plane TEP IP. Well, what is that? If I go back to my cheat sheet, it is a /32, so a single IP address that sort of represents pod 1 from a routing next hop perspective. And I have a unique one, another one down here, 2.22 for pod number 2. That single address will represent sort of pod 2, and sort of for routing purposes, that will be the next hop I would go to reach pod 2, right? But you just need one /32 address for each pod that you have. So I'm just going to go ahead and paste that in there. And then I need a router ID. Again, this is just for your routing protocol good or best practices. You have a router ID that you can identify who's sourcing the neighbor, et cetera, et cetera. And in my cheat sheet, if you were paying attention, it's 111.111, et cetera. If you leave this blank, it will be made a loopback address, and that's perfectly what you want. So that's setting up pod number 1. So we'll go ahead and we will click next. We're at the very end of let's say the first part of the wizard, because we're only configuring pod 1 for the moment. We'll do pod 2 in just a moment. But basically, the wizard is saying, listen, I'm going to create a bunch of objects to connect all this stuff up for you. These are the names that I'm going to choose. Well, all of these are editable. You can make your own name. The wizard gives you what it defaults to, but if you want to use your own naming convention, which most people do, you can go and change all of these things, no problem at all, right? Just so you know that's possible. So I'm going to go ahead and I am going to click finish. And basically it's saying, look, these are all of the objects I created, their names. If you want to see the configuration options of all of that, this is normal as well, because the web server, it says it triggers a restart. So if you want to see what the policies are, you can click on the little blue squares and it will sort of open up a new window and show you what's specific about that policy. If you were into automation, and you remember Chris showed us how easy automation could be in many cases, copy paste, right? If you wanted to look at the config that happens in the background, I know this seems like an overwhelming amount, but you can take that, copy that, and find and replace the IP addresses or whatever, and use it in an automated fashion, right? So it's kind of nice, there's the config right there for all of this stuff, right? So the next thing I want to do is, I want to add physical pods. So it'll take me back here. I might have to refresh my browser because the web server restarted. While that's happening, I just wanted to show you my IPN device. So if I do show IPS neighbor, IP OSPF neighbor in my VRF, what is this here, 1111111? Well, that is just basically a verification that OSPF is up between this IPN device west and my spine in pod 1. That's what you want to see. It means that OSPF is good. That's the first checkpoint that you want to make sure is in place. This other neighbor, don't worry about it. That's my across the IPN routing protocol, but this the 111 is the spine. That's what I wanted to point out. So let's go back here. Let's just quickly refresh my browser. Sometimes I have to do that. I've been having to re-accept certs in my lab. I don't know why, but it's an unsigned cert. So we'll accept that. We'll get right back in. And what are we going to do next? Well, what we're going to do is we have this part set up, right? That's good. That's looking good. Routing is already in place, generic routing in place ahead of time. It's just nothing special about it, just generic routing. Now what we're going to do here is we're going to tell APIC about what the other pod looks like and how to connect it up. So let's go to the second phase of the wizard. Back in APIC, if we click on Add Pod, again, like we did, it'll know that the first stage is done, because if you look at the drawing, now it's saying on the right side of the picture, we need to do pod 2 and get started on those configurations. So I'll click Get Started. And so again, checking the picture, this is the remote physical pod here of pod 2. We need to give that pod a unique identifier. If you remember from yesterday when I did my very early day 0 setup where I had to answer a bunch of questions on the console, like what's your TEP address, what's your infra VLAN, what is your pod ID? Well, pod that we did yesterday was pod number 1. So I'm going to make this a unique one, pod number 2, right? Each pod in a multi-pod environment needs a unique TEP pool. If you remember yesterday, if I click on View Existing TEP Pools, I already chose 10.0.0/16 as the TEP pool for pod number 1. So I need a unique and different TEP pool that doesn't overlap for pod number 2. So me in my infinite creativity, I'm going to pick 10.1.0.0/16, right? So that will make a unique pod that pod 2 can use to its heart content. There is a spine. There should be 2 spines, but in my lab, there's a single spine in pod number 2. What will its number be? You need to have that known ahead of time, and I've chosen 202, right? So that's my spine in pod number 2. And just like the spine in pod 1, we need to know which interface and what IP address I should use to connect to the IPN for the spine in pod 2. So if I go back to my cheat sheet, it's always handy to have it ready. I'm using interface 1/49 for spine number 2 in pod 2, and this IP address of 203. So make sure I remember that 1/49, paste the address. I leave the MTU as default, and we'll go ahead and we'll click next. Now, OSPF, well, we already made some decisions about pod number 1, so pod number 2 just kind of gets those by default as inherited, so we don't have to change anything there. But if I wanted to use a different interface policy, I could make its own policy, or I could just reuse the one I created for pod 1, and that's perfectly okay. So that's what I'll do. We'll go ahead and we will click next. Again, just like in pod 1, we need a data plane type and a router ID. So in my cheat sheet, I chose 222/22.22/24. Now that's the data plane type that represents pod 2. No, I'm sorry, not 24. Max is about to come off mute. 32. It's a single address. And then my router ID 222.222.222. Okay, that's all we need there. We will go ahead and we will click next. And again, this is what the wizard will create. All of these names you can make your own, or you can accept what the wizard defaults as. And we'll click finish, right? We will click finish, and we will say okay, right? I think I triggered a web server restart as well. So what is happening now? So if I go back to my Fabric inventory, let's just be on the safe side and refresh that. So what I'm going to do now is I am going to, ideally, if everything is working, I should see spine number 202, so the spine in my pod number 2, waiting to be registered and discovered. It should be sitting there saying, please, can I securely join the Fabric? And if you remember yesterday, we used the sort of, you're new to APIC, getting started housekeeping wizard. That's my unofficial name for it, right? And we used that wizard yesterday, but since you guys are now intermediate level ACI experts, based on what we did yesterday, I'm going to show you, where you actually can do that, yourself manually if you wanted. So I'm going to go under Fabric, and Fabric inventory. There is a choice called Fabric membership, and if we click on it, we can see the leaves and the spines that represent pod 1 that we discovered yesterday. They're all there. They're already done. If I click on the nodes pending registration, well, what is this? Oh, it's a spine. And I see a serial number, and just like Chris and I talked about yesterday in our best practices, I wrote it down, right? I know that the device ending with 9KT is my spine number 2, and it should be node 202 in pod number 2. So keep that in mind. So what I'm going to do is I'm going to right-click on that single spine and say register. Be careful. It defaults to pod 1, but pick the appropriate and correct pod, in this case, pod 2. We already know that the node ID is 202. That's the number that I chose for it ahead of time. And whatever name you want to give it. So spine-2, again, I'm super, super creative in my naming. And I'm going to click register. Well, what's actually happening? Well, this spine is, let me go back to my drawing so I can kind of show you what's going on. This guy right here, spine number 202, that's the guy we want to discover first. He is sending, he or she, because this could be a she spine, she is sending a DHCP broadcast. Hey, I need an address for me to get configuration. And it is sending that broadcast. It's a DHCP broadcast on VLAN 4. We need to know the VLAN ahead of time in order to know where to receive that DHCP broadcast. And that's why we chose a VLAN, and it happened to be VLAN 4, and that's why it can never change. It's VLAN 4. So that DHCP broadcast arrives here at IPN East, where I've got the DHCP relay configured on this sub-interface, right? So it gets it and goes, I've been told to forward any DHCP broadcast over my routed network over to this APIC listening at 10.0.0.1, which was the relay address. APIC goes, oh yeah, not only do I have an IP address for you to connect up your interface, but I have a little small config snippet that I will include in the DHCP exchange that tells you how to bring up OSPF and fully join the Fabric. So that's going to happen as part of the DHCP exchange. And we can see here, it jumped over into discovering mode. So spine number 2 is discovering. If I go back to nodes pending, well, what's this? Well, this is the leaf in pod 2. And I happen to recognize the serial number from my cheat sheet. So again, just like before, I'll click register. Again, be very careful, select the right pod. This is going to be leaf 104 or node 104. and I call it leaf-4, and I'll say register. In fact, that's the exact same thing we did yesterday, just one by one manually instead of using the wizard, right? So we're going to let those things kind of settle out. And I included this slide for me because I always forget, and I imagine others might fall into the same mistake that I make, is we have just added a spine and a leaf from a different pod. We need to do some additional housekeeping things like out-of-band management IP. We need to, because it's a spine, make spine 202 a route reflector. And then we're going to want to connect stuff to leaf number 4 so we can, connect up endpoints and ping, and I can prove to you that this actually works. So don't forget to do those things, right? So the first thing is, what about the spine as a BGP route reflector? Again, yesterday we used the wizard. I'm going to show you where that setting lives, its proper home. And if that's under the system tab, under system settings, you will see that there's a number of system settings, and one of those settings is called BGP route reflector. All we have to do to turn on route reflection on that spine is basically select it and say submit. Done, right? I mean, don't have to worry about typing any config. ACI knows what to program in that spine, and it's done. The second thing is we need to put out-of-band, well, it's a best practice to put out-of-band IPs on your newly added spine and leaf in pod number 2. Where do we find that? Again, we used the wizard yesterday, but where does that actually live if I didn't want to use the wizard again? Under the tenants tab, we give you a tenant. I didn't really talk about these yesterday, but we give you a tenant called management, and its sole function is just for in-band or out-of-band management, nothing else, right? So I'm in the management tenant, and if I scroll down to node management addresses folder, there's another one here called static node management addresses, and you can see this is what the wizard did for us yesterday. So I'm going to want to add my pod, my new pod here. So let's see, spine 202 to 202. This is an out-of-band address. We group all of these management interfaces into a management DPG, and it happens to be called default. It's the only one I could pick here. You can make one with a name, but I'm just using default. Going back to my cheat sheet, the spine should get this out-of-band IP. Again, being prepared is always nice and makes things nice and easy. We will put default gateway, and we will say submit, and we will confirm that, and we'll do the same thing for node 104. 104 to 104, out-of-band, default out-of-band management EPG. My cheat sheet is 245, so I'll copy and paste that. I know I'm going kind of fast, but we did this yesterday, so this should not be foreign to you. So I'm just sort of showing you a different look, but ideally we're just doing out-of-band. So we've got those things done. So housekeeping is pretty much done. Now the next thing is I actually want to connect something to the leaf, the newly discovered leaf in pod number 2. So here is the goals that I set for myself is I have leaf number 104 connected over a port channel. I have a rack server. In this case, it's a rack server running ESX. So it's got the hypervisor already pre-installed. And I've got some VMs already standing by. But I want to connect that up over a port channel. We did this yesterday, didn't we? I mean, we created things. We connected things to the fabric and we configured that. So I'm going to challenge myself to basically automate that. I'm not going to do it manually because, automation's way more powerful. As Chris got our appetite wet yesterday. So in this case, I'm going to go ahead and connect that up using I'm going to make a REST API call using a tool called Postman. And then we're going to connect up virtual machines and off we go. So you didn't see Postman yesterday, right? Let me close this. Let me close that. But basically, I created a REST API call called add ESX 108 to ACI. This is the URL, right? This little thing is my APIC as a variable. It's a post command, which means I want to write. I want to send and write configuration to my APIC. And the body down here is basically all that's needed to connect that up. Now, I chose XML here. How did I do this? Well, Chris showed us the API inspector yesterday. I basically created the configuration once manually and then I just copied and pasted it and save it forever and just reuse it and reuse it and reuse it. So the first thing we need to do is we need to log in. So this REST API call is a simple login with username and password. So I'm going to send that. I get a status 200, right? This is our using HTML codes, right? HTTP codes, right? 200 means good. 404 means not found. 500 is forbidden. Same thing applies here, because what is a REST API? It's just it's the model that we use for the web for HTTP, but using not sort of web pages and HTML files, but object models that are used in API and in ACI. So this is just using the same exact model, but just for a different purpose, if that helps clarify it, right? Because I have a URL, I have a body, I have a job post, get, those kinds of things. So I'm logged in. I got a cookie here that needs to be cached. So the real call that I want to make here is attach ESX 108 to the fabric. And it looks good, 200, okay. I mean, how fast was that, right? If I did this manually, if I click fast and I shut up for a minute, I could probably do it in like 5-6 minutes, make sure everything's right. Here I did it in 100 milliseconds or less, right? If I just click send. So that's set up now. That's done in ACI. So what I'm going to go is over here is now I want to add to my DVS that we created yesterday. I want to add that host that I just created. So again, I could right click and do it manually, but that's no fun. I actually also want to point out that you can use automation. In fact, one of the fundamental benefits of automation is you should be able to use it data center wide. Not just, I use this tool for this vendor because they make me, and I have to use this other tool because they use, no. It should be any tool you want with any vendor, right? So VMware has an API, vCenter does. And so I'm already logged in. So I wrote a little script. I think I call it DVS 108 attach. So I'm gonna go ahead and do that. And as long as I'm logged in, yeah, it's working. What's happening over here in just a second, we'll see. There's my host, right? It's a very simple script that basically automates connecting an ESX host. Again, just to show you that automation is data center wide across different infrastructure, different vendors, different vendor logos, whatever. It all should work well together, and it does in this case. Okay, so I got my host on there now. So I've got goal number 1 is done, right? Goal number 2, let's connect up some virtual machines and communicate across pods, right? So now that I've got that set up, let's go back to a virtual machine that I have here, and it's called Win8 pod number 2. Notice he is sitting on the ESX server that's across into pod number 2. So we need to put him into a port group. Now, thankfully, I've got port groups there because we built them yesterday. Silver, gold, what do you want to do? Let's do silver. So we'll put him in silver, him or her, and we'll open up the remote console of Win8 pod number 2. We'll let that kind of take a moment to connect up. I think I've got gold and silver already working. I don't know why it's thinking for so long. That's longer than normal. Okay, let's clear this. Let's do an IP config so we know what we're working on. This is 1.20. So where is this endpoint? It's part of tenant Acme. It's part of the bridge domain A that we created yesterday, and I just dropped it in EPG Silver, right? So the first thing we should check is, can I ping my default gateway? And I can. That's the first good sign that, I know that my data plane is working into the ACI fabric from the virtual world. This is, again, a benefit of the VMM integration that we showed you yesterday. Now, the real trick is I should be able to ping my other friend here in the same EPG as me. So this is technically layer 2. They're in the same broadcast domain, right? 1.11. Can I ping 1.11? Don't need any contracts because they're in the same EPG. And in fact, I can ping, right? What about broadcast, unknown unicast, multicast? Well, how do I create a broadcast? Well, fortunately, in my massive Windows experience going all the way back to Windows 3.1.1, is if you ping a Windows device by host name and you do not have a Wins server, it sends a broadcast saying, hey, what's your host name? Who has this host name? So if I ping Win8-Silver, it'll send a broadcast to it, find him, and if the ping works, we know the broadcast worked. That's Joe's quick and dirty, does broadcast traffic work? I mean, clearly you would test more robustly, but just to prove to you that broadcast traffic is in fact handled across the IPN, just as Max described it. So I remember before, while Max was doing his lecture, somebody was asking, can I stretch layer 2 across pods? And yes, you absolutely can. And this is what I've just shown, because these two guys are on the same layer 2 segment in the same network and talking basically at layer 2. So the next question becomes, okay, well, what about layer 3? What can I route and ping into different bridge domains and different endpoint groups? And the answer is, of course, yes, you can. So let's quickly do that. Let's go back into APIC. I didn't have time to automate this part, and I probably should have. So let's go back to our tenant Acme. And if you remember yesterday, we only had a single bridge domain called BDA. So I'm going to create a new bridge domain, right? And I'll call it, we'll get creative here with the name, BD-B. We'll put it in the same VRF that we built yesterday, the only VRF that I have. We'll click next. We're going to give it a subnet, a different subnet here. So 192.168.4.1/24. I'm going to say advertised externally because I think I might want to get this guy to the internet. I'll make this address primary and we'll say okay. Let's go ahead and add our layer 3 out while we're here. Why not, right? There's my layer 3 out from yesterday to the internet. And we'll click next. Don't need to do anything here, so we'll click finish. So we've got BD number B, or BD letter B. Now I want to create another EPG, right? I'm going to call this EPG servers. Okay, so I'm going to right click, create this one manually, servers. Going to map it to bridge domain B, right? Different network, different bridge domain, and say finish. And then, if you're remembering yesterday, I need to establish EPG membership. I'm going to map it to my VMware VMM domain, which we created yesterday. And if you remember, we called it VC_DVS. And we'll just take the defaults, and that is all good. So just if you want a visual of what I just did, is I probably should have showed this slide first, right? VM, actually, I think I used VM Silver, right? VM Silver to VM Pod 2, and actually they were technically on EPG Silver, just so you know. Those guys were the layer 2 ping that I just showed. Now I just created EPG Server, and I have this guy over here that I'm going to add at 4.100. Will he or she be able to ping across the pods as well? And the answer should be yes. So can two VMs talk in the same EPG? Yes, we proved that. Can they talk in different EPGs, different subnets, different bridge domains? Let's go back here. You will notice that I don't have any contracts. So I think I need to do that first, right? So if I'm going to talk to Silver, Silver is consuming something. So I think I need to make it provide. Let's provide that same contract as well. Well, no, he's consuming. That's cool. We'll leave it consuming, right? I know Max is about to come off mute. Servers will be the provider. So we'll go into the new servers EPG, and I will click on contracts and make a provided contract. So we can establish communication between EPG Silver and EPG servers, right? So I'm just basically making that contract association. And if you want the visual, we can always look at the canvas topology like we showed yesterday. And we can see here is EPG servers. There is a contract relationship between them and Silver. So let's go and put something in EPG servers. So I have a Windows Server 2016 at the address 4.100. Let's go ahead and put this person in the EPG servers that we just created and mapped. We just did that. So again, this should be somewhat familiar because we explained all of this yesterday. Let's go ahead and open up the console of this newly added server into the servers EPG, and we'll bring this up and let's clear up the mess and let's do an IP config so we know what we're up against. 4.100. So the first thing is, can I ping my default gateway? Yes, that's good, right? So this, can I now ping 1.11? He's in my same pod. Yeah, that's looking good. Can I ping 1.20? This is the endpoint in the other pod, and I can. Wow. everything is working just as I had hoped, right? So that is the green, I'm sorry, the light blue EPG server, where I added something here, but I made it talk across pods, across different networks, just so that we're all clear on what just happened, right? So that, let's actually test and say, can this guy get to the internet? Because remember, we had our layer 3 out, and he can't. Why can't he? Well, it's probably a contract issue. So let's just go and look at my layer 3 out from yesterday, and we will look at the contract that we have. In fact, I can see it's common default. I should have just looked at the picture. I'm using common default to get to the internet. That's the name of the contract, by the way. So if I go here and I consume that contract, common default, which is basically a permit all contract we give you out of the box. Now, if I were to do that, now I can get to the internet, right? So again, doesn't really matter. I think, can pod number 2 get to the internet, right? Does routing work across pods to the internet using a layer 3 out? And in fact, the answer is yes. So I can do anything I want, get anything I want, configure the policy in a very flexible manner in this single administrative domain, the multi-pod. But remember, each pods are independent with their control planes and their data planes, right? But the management plane is unified, so it makes it easy to manage. So with that being said, I will pass back to Max, because I believe we should now talk about multi-site. Max, I didn't show the links in the white paper, so if you can do that real quick for me, please.
I will absolutely do.
And let me make you presenter. Okay, you are golden.
I am, so you say. Okay, let's see. Okay, so before we continue, these are the links for multipod. There is a white paper. There is a multipod configuration paper that drives you through all the steps that Joe also did, right? Both for configuring the IPN devices and also the wizard. There is a multipod and service node integration white paper if you want to do service graph with PBR. It will tell you all the options that work with multipod. And then there is the breakout session, the latest, unfortunately, available from a live Cisco Live, which was Barcelona 2020, presented by my friend and colleague John Weston. So you can also go and see a 2-hour, I think it's 2 hours or 90 minutes presentation that goes more into the detail of multipod. But to summarize everything you have seen so far, right, multipod equals simple, right? Simple because after you bring up to the wizard the pod, you saw that the second pod joins automatically the fabric. You don't need to touch anything other than cabling. And you don't need to do anything to allow an EPG connectivity to be extended to the second pod, right? In virtue of the fact that you define that EPG on Epic, that EPG is available across all the pods, all the leaf, inside the same pod or across pods that are managed by the same Epic, right? So it's the easiest way to deploy DCI if you want, right? Now, I've seen several questions where people were like, oh, I still do not understand why multipod versus multi-site. Again, multipod is very easy, but it could potentially create problems if, as I said, you delete an EPG, the same way an EPG is made available across all the pods. When you delete an EPG, that EPG is gone across all the pods at once, right? So you have a single change domain. It's a single admin domain, but it's also a single change domain where tenant policy that you change apply to all the pods. Obviously, in ACI, we have the concept of multi-tenancy that allows you to deploy, to basically configure policies, different policies for different tenants. And normally, if you are making a change to a policy in tenant 1, you cannot create problem for tenant 2, right? Because you don't even see the policies of tenant 2, especially if you use role-based access control to provide access to the tenant resources only for the specific admin of that tenant, right? So there is a multi-tenancy built in ACI that gives you that separation, but in the context of the tenant, you have a single change domain, okay? Multi-site, we will see, may change that, and I say may, and I will clarify why I say may when I come to the tenant and policies management with multi-site, right? We'll talk about that later. So before we go there, let's do a quick introduction about multi-site, right? So if you look at the picture, right, eye level, you're like, okay, this is the same picture you showed me before, right? The same picture of multi-pod, where there are two main differences. Difference number one is that instead of having all this ACI network managed from the same Epic controller cluster, which is stretched across sites, now I have each site, each fabric has its own Epic controller cluster, right? So each site, each fabric, is its own network with this control plane, data plane, and management plane, okay? And we interconnect this network with each other through an external network. Before it was called IPN. Now I call it generically IP network. Sometimes you find the name ISN, Intersite Network. The main difference is that what Joe showed you, right, when you send a broadcast across pods, you need to have multicast running in the IPN network to carry that broadcast or BAM in general, BAM traffic across pods. In multi-site, if you were to extend layer 2 across the sites, which as I said is possible, right, and you were to extend layer 2 with flooding associated, and you want also the flooding to go across the sites, that traffic is not carried using multicast in the external network, but is carried using an ingress replication functionality on the source spine that basically replicates that layer 2 frame to all the remote sites where the bridge domain has been extended, right? So that's the main differentiation, which essentially ensures that that IP network, what it needs to do is truly only IP routing, right? It doesn't, and it needs to support the higher MTU. And we'll talk a little bit more about the ISN in a second, okay? So that's the second big difference between multi-pod and multi-site. The third difference is we still use in multi-site a data plane, a VXLAN data plane to establish connectivity site to site. Again, this is done to abstract the physical location of the endpoints from the type of connectivity I want to establish. It doesn't matter if the endpoints are in the same fabric or in separate fabric. If I want them to connect a layer 3 or a layer 2, I can do that with a simple policy because I use VXLAN to carry the traffic wherever it needs to go. And the PBGP VPN is still the control plane that runs between the spines, in this case of different fabrics, instead of different pods, to exchange the reachability information that allows to build that VXLAN tunnel. There is a difference how this EVPN control plane is used. It's obviously much more controlled with multi-site because we exchange endpoint reachability information only if there is a contract in place that says my EPG in Fabric 1 needs to communicate to my EPG in Fabric 2, right? If I don't have that contract in place, I don't exchange any reachability information because I may not need these EPG to talk to each other, and I don't want to send information across fabrics unnecessarily, right? So multi-site gives you a much better control on the information that you share across sites, on the type of connectivity that you can create across the sites. But once you say, I want this EPG to talk, to communicate, a layer 2 or a layer 3, the mechanism that allows the traffic to go across is essentially the same on multi-pod, right? The use of VXLAN, data plane with the VPN control plane. But the other difference is that since now I have these different Epic domains, and what I want is to give you the capability to say, you know what, I don't care where my endpoints are located. I want to be able to describe the policy, the configuration I want. I want EPG1 to talk to EPG2 with this security policy. That's my intent. That's what I want. Where the endpoint of EPG1 and EPG2 are connected, it does not matter, right? The architecture should take care of allowing that communication. And that's why we bring in a third component with multi-site for the solution, which is the multi-site orchestrator, right? And the multi-site orchestrator, we'll talk about that, is basically what allows you to create the policy that says, I want EPG1 to communicate with EPG2, and I want this to be the rule, the contract that dictate the security policies between the two EPG. At that point, once I push that configuration to the Epic domains in Site 1 and Site 2, these two EPG will start communicating site to site. And we will see that in action with Joe, okay? But this is basically a new component that now we need. We didn't need it in multi-pod because I was doing that single expression of my intent, EPG1 to EPG2 with this contract, on Epic directly, right? Now I cannot because I have different Epic domain and I need all of them to understand what I want to do, right? And so the single pane of glass where you do that is the multi-site orchestrator. The use cases for multi-site, large service provider, they want to build a data center network which has more than 500 leaf nodes, right? So they exist. They are obviously not the majority of our customers. Otherwise, our stock would be at $7,000 today. But we have several large customers, especially in the service provider, that need to build 2,000 node, 3,000 node fabric. And obviously, there is no way to put all the leaf under the control of the same controller. It's not good from an implementation perspective. It's not scalable, but also from a failure domain perspective, right? You don't want to, or management domain perspective, you don't want to have all these eggs in the same basket, okay? So you want to divide this large number of leaves into different fabrics that then you can manage in a cohesive way using multi-site, right? So this basically, it's multi-site using a physical data center location where each of the sites is actually a fabric. So site, it's a little bit a confusing word because sometimes it's associated to a physical location, but really when we talk about sites in multi-site, we're talking about fabrics, okay? If all these fabrics happen to be built in the same physical location, physical data center, you can still deploy multi-site to interconnect them, right? But they're not obviously separate physical site location, okay? So that's use case, the scale up, the deployment of a data center fabric. Data center interconnect, obviously. Multi-site we will see has been built. There is no latency limitation across the fabrics that are part of the multi-site domain. I can actually manage from MSO fabrics and sites that are deployed across the globe, like the picture that you see here. This is not just a slide. It's a real deployment that you could do where you can manage data center in Los Angeles, London, Delhi, and Tokyo from the same multi-site orchestrator controller, okay, instance. Third use case is cloud ACI, and Domenico will talk about this tomorrow. As I told you, once you understand the architecture of multi-site, you will be able to appreciate how basically it's replicated also for the cloud ACI story, right, for the hybrid cloud connectivity. And the last use case is the use of MSO as a way to provide the SR MPLS and DOF, which is used by many telco customers. I list this here because MSO allows you to provision this SR MPLS and DOF, but it's really not in the same category of the multi-site use cases that we actually discuss in this training, right? In our case, we use the inter-site network and VXLAN to establish site-to-site connectivity. With this specific use case, we use instead the L3 out and the SR MPLS and DOF into an external SR MPLS network, even to establish data center to data center connectivity. But since that connectivity can be provisioned by MSO, I'm listing that as a use case as well. And if you're interested, reach out to us, and there is a white paper actually that talks about also the SR MPLS and DOF. It was recently delivered. As I said, one important component of multi-site, like it was in multipod, is the infrastructure that interconnect the sites. Now, while we multipod, I told you it's very common that IPN is very simple because usually I have dedicated connection interconnecting my pods, right? With multi-site, that inter-site network can be really extending across the world, right? Could be a combination of public and private network, which basically makes important to ensure that to build a VXLAN tunnel site to site, I can actually have TAP addresses assigned to the spine of the different fabrics that can be routed in the inter-site network. And if the inter-site network is a public network, it means I need to use routable public TAP addresses, right? Which brings, you will see when Joe does the configuration, you basically assign these specific addresses when you onboard the fabric into the multi-site orchestrator. So these addresses are not taken from the original TAP pool that you used to bring up the fabric, which is what you saw yesterday, because two reasons, right? That original TAP pool may be not routable, and also you may have fabrics that you built independently, they use overlapping original TAP pool, right? They should be able to be onboarded in the same multi-site domain, so we cannot rely on establishing connectivity between TEP addresses that are taken from the original TEP pool, right? That's why these additional external TEP addresses and also addresses that you assign to the spines for when you onboard the fabric are required. And you will see that in the lab, okay? The InterSite network is not managed by the EPIC or by MSO. It's a separate network. It's a separate network that, though, it just represents a transport, okay? So I just need to provision it once, and then no matter how many VRF, how many endpoints they need to communicate across sites, I don't touch the InterSite network anymore, right? Once the sites are connected to the InterSite network and they can create a control plane EVPN between them and a data plane VXLAN, the InterSite network is just routing traffic, okay? So it's very simple to operate because of that. The topology can be whatever you want. As I said, we can stretch across sites. What we require, like in multipod, to use OSPF only between the spine and the directly connected device of the InterSite network. Inside the InterSite network, I can use whatever I want. I redistribute OSPF into BGP. That's very common when InterSite network is a backbone of an enterprise. But I need to use today still OSPF between the spine and the InterSite network device. And I need to create these interfaces like layer 3 point-to-point sub-interfaces, right? Exact same consideration that you saw with multipod, with the VLAN tag, the magic number 4. There is no multicast requirement in the InterSite network, and we need increased MTU support, right? So it really depends what is the MTU of the endpoints that connect to the fabric, right? If you have endpoints that all use 1,500 bytes, all you need in the InterSite network is 1,550, right? So 1,500 plus the 50 extra for VXLAN. But you need to remember to change the control plane MTU, because by default, at the EPIC level, and that's a global setting, the control plane packets can, generated by leaf and spine, can go up to 9,000 bytes. That's a global command that you can tune, and this is explained in the multi-site paper that I'll show you at the end, but you need to go in the global setting of the EPIC and reduce that value from 9,000 to the value of MTU that is supported across the specific InterSite network that you use, right? Could be 2,000, could be 1,600. That control plane traffic is not the VXLAN encapsulated, so you just need to match the control plane MTU with the MTU that you have in the InterSite network, okay? What is the multi-site orchestrator? The multi-site orchestrator is the main actor of this multi-site architecture. It is basically a cluster of 3 nodes, okay? Like in EPIC, we have 3 nodes. You can have more. With the multi-site orchestrator, we only need 3 nodes. And these 3 nodes could be virtual machines that you bundle together, and that's your cluster, or could be installed as application on top of a physical server that we call it service engine today. It will become the Nexus dashboard later this month, okay? So you have two flavors to install the multi-site orchestrator, as a virtual machine or as an application on this service engine or Nexus dashboard. I don't go into the detail here, but you can find all the detail in the multi-site paper, right? So don't worry about that. The important point is that these 3 nodes are bundled together. In terms of connectivity, they just need to connect to the out-of-band address of the EPIC, right? So the MSO nodes do not need necessarily to connect to the fabric, differently from EPIC that needs to be connected to the fabric, to the leaf. So you can connect the MSO node wherever you want in your infrastructure, as long as they can communicate with the EPIC out-of-band address. And in terms of latency, since these 3 nodes are active, and so they basically distribute information, they have a database that they keep in sync between them, they need to be in proximity with each other. And when I say proximity, I say 150 millisecond RTT is the maximum latency that has been tested between the MSO nodes, okay? But it's already a good latency, right? It gives you already enough flexibility to distribute them in a way that you reduce the chances of losing more than 1 node at a time, right? What is more important, the latency between each of these MSO nodes and the EPIC that they manage can go up to 1 second, right? And up to 1 second means around the world, right? That's why, as I said before, the picture where I show you where there were sites in US, Asia, India, and Europe, you can manage all these fabrics from the same MSO cluster because we can go up to 1 second. The only recommendation is do not spread the MSO nodes themselves across different continents, right? Because you could go above this 150 millisecond latency if you do that, okay? The last thing I want to cover is the difference between EPIC and MSO, right? The same way, MSO is not replacing EPIC. There are some functionality, everything you have seen yesterday, right? The fabric bring up from scratch will continue to be done at the EPIC level. The creation of physical domain, VMN domain, attaching fabric access policy to attach host to the fabric continue to be done at the EPIC level, okay? What MSO deals with is to basically the management. It's basically the day zero infra configuration that allows the fabrics to be onboarded and to be connected to the intersite network and to start peering EVPN with each other. Okay, so that's something that you do day zero, and Joe will show you. Once the fabrics are interconnected with each other, you can start deploying tenant policies. And really, MSO deals with the definition and the deployment to the different fabrics of these tenant policies. And when I say tenant policies, I say VRF, EPG, bridge domain, etc. Right? And we will see that in action, right? So it will never, MSO is not a super EPIC. It will never replace EPIC. They will always be complementary, but the assumption is most of the operation, once your fabrics are up and running and they're connected to the multi-site domain, most of the operation in terms of creation of policy, etc., will be done directly from the MSO. Okay? And now we have the first lab where we're going to build on top of what has been done so far. So we moved from one pod. We became successful, me and Joe, with our enterprise. We built a second pod because we expanded our fabric. But now we need to build a separate fabric for disaster recovery reason, for resiliency, and that's where we're going to add a new fabric to the multi-site environment that we already built. So, Joe, ball back to you if I'm able to pass it.
Yes, and I think here it's appropriate to maybe take a 10-minute break. I know some people were asking for it. So can we take a break, Federica, until Central European time? It is 14:32. Can we come back at 14:43? So 10 minutes from now. It actually just ticked over when I said that. So 14:43 Central European time, which is 10 minutes from now, we will resume once again. So also please pause the recording.
Okay, thank you.
In 10 minutes. Okay, Rafaela, I think we can start the recording again.
This meeting is being recorded.
Okay, welcome back from the break. If you're coming a little bit later, you can catch up on the video when you get it. So thank you, Max, for the lecture on multi-site. Now let's have a look at how we would build this in a real fabric. So we know that just before the break, when we talked about multi-pod, I have 2 pods. That's sort of in this area here on the left of the screen with my IPN devices and all that stuff connected. We just built that and proved that it worked. Those 2 pods together will represent a site in a multi-site environment. So I'm going to call that site 1 Amsterdam because that's where it's based. And then if you look here on the far right, we have the sort of salmon-colored spines and leaves. This is a completely different site, different geographic location, completely independent spines, leaves, and apex. So these, at this moment in time, are completely separate standalone fabrics, right? And that site on the right will be site number 2, and that's represented by Barcelona. So if you see me reference Amsterdam or Barcelona, that's site 1 and site 2. Now, we want to connect these sites together because we want to be able to share and extend networks or route between subnets and share policy, blah, blah, blah. So we need two things to do that. The first is we need this thing called the multi-site orchestrator, which Max just talked about before the break. It is simply a management, it's a set of 3 virtual machines that are acting as my manager for a multi-site environment. That's all they are. They're just sort of higher level policy managers that allow me to easily create policy once in MSO and then choose where I want that policy to live, in site 1 or only in site 2, or maybe in both sites. I want to share policy, I want to stretch networks, I want to share contracts and layer 3 outs, whatever. We do all of that through this thing called MSO. So you're going to see us use that today. That's the first thing that we need. And I've already got those installed and set up. We don't have time to show you that, but it's trivial to do. The second thing we need is some kind of data center interconnects between site 1 and site 2, right? So I have, this is my lab. So I basically borrowed a free interface on my IPN East and pretended it was, going across a LAN. So technically both of these sites are not in different data centers, but they're set up to be that way behavior-wise. So I've got this extra link. So the first question is, wait a second, you've got multi-pod. Now you're going to do multi-site. Can I do those 2 together? And the answer is absolutely yes, you can. So if you really think about it, scale can go really, really big because I can have multiple pods and multiple sites. And I think Max, I don't know if you mentioned maximums, but we're talking like what, 1,200 leaves maximum across everything? That's a pretty big fabric. If you're that kind of customer,
Yeah, actually, if in multi-site, you mean?
Yes, multi-pod and multi-site together.
Well, it's 500 the maximum multi-pod. You can have 12 multi-pod fabrics, so it's 12 times 500. Still, it's 6,000 leaves in a multi-site
only 6,000 leaves. Okay.
Only
where do I send the PO?
Yes.
Okay, so we need a data center interconnect, and that is a job that multi-site orchestrator will also help us set up, right? Because you've been hearing us throw around terms like VXLAN and MPBGP, and many of you know what those are, but many of you, it might be your sort of first exposure to them. So it's really simple if you keep it in mind. VXLAN is a tunneling technology, and we use it here exclusively for data plane. So when an endpoint in site 1 wants to talk to an endpoint in site 2, we're going to go through a VXLAN tunnel to send that data. So that's pure data plane, right? And that's a tunneling technology. That's really all it is in a very, very simplified manner. When we want to share information about how to reach endpoints, like where is this endpoint? What bridge domain is it in? We use a control plane protocol to share reachability information, right? That's what they're for. And we chose multi-protocol BGP because BGP is the only protocol in a multi-protocol fashion that allows us to carry and share reachability information, not just about IP addresses, but also MAC addresses. And also BGP is multi-tenant, so we can go all kinds of crazy tenants and VRFs if we wanted, right? But it's basically just we're using MPBGP as our control plane so that the pods and the spines can share information about their endpoints with each other and how to reach them. That's really all it is, right? So if you got confused along the way at this point, that's kind of like the Joe's 60-second primer on what those things are. So we're going to do everything here in MSO. And the first thing that I'm going to do before I hand back to Max is I'm going to set up the ISN. And I am going to show you how we set up that data center interconnect across that ISN using MSO. And it's actually really, really easy. So, I mean, to me, that's one of the nice things that MSO does for me. So just like before, it's a good idea to have your decisions about interfaces and IP addresses done ahead of time, right? So I expanded my cheat sheet for doing multi-pod with multi-site. Now, you'll notice all of the variables you see here that are in black text are ones that we used already in multi-pod, right? Multi-site orchestrator will be aware of those, and we can actually reuse them. In fact, we're going to reuse the same layer 3 out that we set up for multi-pod. Like I didn't show you where that layer 3 out was. I'll do that now. So any of the numbers or variables that you see in red are things that we have never configured before and we will have to add in multi-site orchestrator, but that's easy. We've already decided what those things will be ahead of time. So I think the ones that are probably most important is we have a multi-site OUTEP. What the heck is an O-UTEP? It stands for Overlay Unicast Tunnel Endpoint. So basically, when we have unicast traffic, so data plane traffic between, let's say, two endpoints, right? We are going to send it across a tunnel to this endpoint to reach the other site. Effectively, I'm simplifying, but we need an address to sort of anchor that end of the tunnel for unicast traffic in a multi-site environment. So we need to pick those. There's the next column, the multi-site OMTEP. We have all these fancy acronyms. Overlay multicast tunnel endpoint. So multicast traffic we treat specially because we want to be very efficient about how we take that kind of traffic and distribute it. So we create a special tunnel endpoint just for multicast traffic. And without getting into all the details of how that works, we just have a special tunnel for multicast and a different one for unicast. So we need addresses for those. So those will be, those are choices we will make for IP addresses, and we'll just configure them in MSO. So let's actually go over to my APIC. So the APIC that you're seeing right now, this is the APIC that we've been working with for the last 2 days. I have a second APIC, a completely different APIC in site number 2, Barcelona, with its own APIC, its own single spine and 2 leaves, right? So that's called APIC 2, right? The other one's APIC 1, but it's different sites, right? So I've got these 2 different APICs open, right? What I need to do now is I need to go into multi-site orchestrator, and I'm going to log in. And this is a brand new multi-site orchestrator. You can see I'm using not an official build. I'm using a very recent nightly build of the current version that's coming. It should be out any day now, I think. But I'm using let's say the unofficial earlier versions of it. So everything should work fine. But if I hit a snag, I'll blame that. Okay. So here we are. This is what you will see when you first log into multi-site orchestrator. It's basically a blank slate. But the first thing you need to do is you need to tell MSO about your different sites, right? You basically need to connect them up so they can actually talk to each other, because when we devise policy in MSO will then make a communications call to the APICs and say, hey, configure these policies that I just brought into life. So the first thing we will do here is add your first site. So we'll click that button. We're going to give this site a name, and I'm going to call it AMS because this is going to be my site number 1. You're going to need to give it the IP address or name of the APIC, right? You can hover over the little help button and you can see, right? So I have DNS in my lab. So this is the URL to the APIC front-ending site number 1. We're going to need admin level credentials or read-write level credentials because we are going to be pushing policy, creating policy. So we will put the admin and password of the APIC in site Amsterdam. And then we're going to give it a site ID. If it's your first site, I just say start with 1, right? Make it easy. And that's the first part. I click save. The second task is more like a fun optional task, in my opinion, is you get to drop a pin on the map where this site actually lives. So this one lives in Amsterdam, and if there are any Dutch people on the call, don't get mad if I, put you into Flevoland instead of North Holland. I think probably right about there, right? I would say it doesn't really matter. It's kind of just a reference for you, but I always kind of make fun of not dropping the pin in the right latitude and longitude. So you can see here, we've established a connection to that APIC from MSO. We can see the state of this fabric is generally healthy, right? That's a good first sign, but we need to add our second site now. So let's do that. Call this one BCN, and I'll put the URL. This is a different URL to a different APIC, right? It's just one number different, but it's a different altogether. Again, same thing. I need credentials to be able to log in and affect and make changes to that APIC. And this is my second site, so I'll give it a site ID of 2, just like before, and say save. And now we'll make sure that we end up in Catalonia and not the Pyrenees. What would you say right about there, Max? I would say that's good. Again, it doesn't really matter. It's just for visual reference. So there we go. Very, very easy for me to set up a channel of communications between MSO and APICs for purposes of management, information sharing, and configuration, right? So that's the first part. The next part is something that we call the infra configuration. If you remember from my drawing, I said I needed to create a data center interconnect here, right? And now normally you're probably thinking, well, when I hear data center interconnect or DCI, I'm thinking something like OTV. Is that what you're using? No. Actually, we're using a much simpler, more modern approach here for data center interconnect being effectively VXLAN. It's a VXLAN tunnel between them. That's all I really need to set up, right? So that's what we're going to do in MSO. So where do I do that in MSO? This is the easy part, right? So I'm under the infrastructure tab on the left, and there's an area called infra configuration. And we can see we've got our 2 sites here, and we can hover over them and get information about health and faults and things that we might care about. But notice there is no line between them, not yet. In order to establish that, we need to click the button here, configure infra, and we have to basically fill in the cheat sheet that I already created. So the first thing is there's some BGP parameters here. These are the default values out of the box. I don't really see any reason to change any of these. If you have a very good reason, you can, but I just leave them as the default. There's no reason for me to change any of those, right? So the first one I want to set up is Amsterdam. So I'm going to click on the list of sites here on the left. You can see my 2 sites that are connected. Is AMS, and it says disabled. Well, basically, I haven't brought it in fully into the multi-site data center interconnect. So what I want to do is I want to first turn on multi-site here, basically telling MSO, yes, it's okay for you to push config to this device. It already pulls in information that's pre-configured on that APIC. If you remember yesterday, if you were paying attention, my BGP route reflector autonomous system number was 65,002. Well, it populated that for me automatically. I can change it if I want, but I'm not going to. So you can see that like my multi-pod things, my policy, remember I created this MPod OSPF policy. It pulls that stuff in from APIC for me, right? Because one of the nice things about ACI in general is this notion of create policy once, reuse that policy wherever you need to for eternity, right? It's a work saver. It's a consistency approach. So there are some things we need to configure. So if we look at the middle pane, there are actually 3 areas we need to configure. First, at the site level, which is why the blue frame is around this, but I will then later on go down to the pod level, and then I will go down into the spine level inside the pod. So let's start at the top, the site level. The first thing it's asking for is, hey, I need an overlay multicast TEP. That should be a familiar term now, because from my cheat sheet, I have an overlay multicast TEP, one address, one tunnel that is going to handle both of my sites, both of my pods, pod 1, pod 2, that comprise site 1. Just need one address, one tunnel. The spines will take care of it. It's what's called an anycast address if you want to get technical. So it will kind of live on all spines, but I only need one address is the important point here, okay? So all I'm going to do is paste it in there, right? That's pretty easy. That part's done. I'm going to click down to the pod 1 level, and it's saying you need an overlay unicast step, right? Well, if you go back to the cheat sheet, I know for pod 1 it's 11.20, and for pod 2 it's 11.21. I just need one address for each pod. That's all I need to do. So I'm going to paste that in. Then I'm going to click down onto there's nothing else to configure here yet. I'm going to come back to external tuples later on today, but I'm not going to configure them yet. So they're an optional thing for certain situations, which we'll get into. Clicking down into the single spine I have, normally you would have multiple spines here, is notice it says, oh, well, you already have a link from the spine to the ISN or IPN, and it's using 1/25 at this address. They kind of made the text small in the new UI, but you can see it's already there. What is that referring to? Just so we're clear, remember when I'll go back to the multipod image. Remember when we first set up multipod and we talked about connecting this spine to this IPN device? Well, it created that OSPF adjacency, and like I said, it didn't show it to you, but it created a layer 3 out for us in the background. And we know what layer 3 outs are. It's how we route outside of the fabric. So it seems natural. Well, multi-site orchestrator says, hey, I see that you already have a layer 3 out ready to go. I'm just going to reuse that. In fact, you have to reuse it. We're going to reuse the same thing. Why do the work twice? We can use what we already have. That's what this is here. So I'm going to turn on something. I'm going to turn on BGP peering because this is going to allow me to peer between sites now, not just between pods, but between sites. And it's saying, well, in order to do that, I need a BGP EVPN router ID, such a fancy word for basically what's a loopback address. If you hover over the little informational icon, it knows, hey, I see that you already have one configured for multipod. You can reuse that if you want, or if you wanted, you can create a unique one for multi-site. It's your choice. I'm kind of lazy, so I'm just going to go ahead and reuse what I had already in place for multipod. No need to do the work twice. So I'm going to leave that. I've configured there. Let's go down to pod number 2. I need an overlay unicast TEP, just like I did with pod 1, but a unique one that identifies pod 2 for unicast traffic. All right, that's what I need. And then clicking down into the spine in pod 2, again, same thing. It says, hey, I see that you have this layer 3 out connected for multipod. I'm just going to go ahead and reuse that. That's good enough for me, right? So I'll just turn on BGP peering. Again, same thing. I need a loopback or a router ID. You already got one in place for multipod. Do you want to reuse that? Well, yes, I do. Or I don't have to, but I do want to. So I'll type that in. That is site number 1 done. That's pretty easy, right? So the benefit here of having done multipod first is we got to pull in existing configurations and just kind of say, yeah, I'll reuse those. So we didn't have to do a whole lot. Now let's look at the other site, Barcelona, and say, well, we haven't ever configured anything for this. This is a brand new site I'm adding for the very first time. What do I do? How does it look a little different? So the start is the same. I'm clicking in the site at the site level. I'm going to turn on multi-site first. I'm going to need a multicast TEP just like before. Let's go to the cheat sheet for my multi-site. Where's that? And for multicast overlay TEP, here is the address I have chosen. So I'm simply going to copy paste. That's pretty easy. Autonomous system number. This is basically what I had already configured in the APIC managing this site. I've already done fabric discovery. I should have mentioned that. I've already done fabric discovery and the basic standalone fabric housekeeping setup for the site number 2, right? That's already done. I'm not going to do that again. Otherwise, we'd be here until midnight. So anyways, it pulled in that information, but it doesn't know anything about OSPF because, well, there is no layer 3 out running there for purposes of multi-pod or multi-site or anything like that. So we need to tell it. So in my case, it's also area 0. The area type is a regular area. That's fine. I mean, your choice could be NSSA. External routed domain. This is an optional field, but I did have one created. If you remember from yesterday, I talked about this concept of domains in ACI. It's either it's usually one of two things. You're either a bare metal device or you're a virtual machine, and we call those differences domains. There's a third kind, and it's called a layer 3 routed domain, just another kind for layer 3 outs, and I have created this object so I can refer to it here, right? It's being imported from APIC. I've got some policy pulled in. I want to go and actually affect this policy because in my environment, I choose to do MTU ignore. I like to advertise the subnet, and I use bidirectional forward detection. So I'll set those settings in the policy that is here, or I could create a new one if I wanted, with a different name, whatever. But that's all we need at the site level. Let's click down into the pod level. In site number 2, there's only one pod, so of course pod 1 is all you see. So we need an overlay unicast step. So again, we'll go to our cheat sheet here, and we will say there is the IP address 33.20 that we chose for this TEP. So we'll paste that in. We're really high tech here, copy paste. And then we're going to click down into the spine. There is no port, there is no IP address, nothing's been done before, so it's a clean slate. So we'll do something a little bit different here by clicking add port. And all we have to do is go back to our cheat sheet. And in my environment, I chose Ethernet 1/25, and I chose this IP address to exist on the spine that's handling site number 2, so that I can create my OSPF adjacency to the intersite network, and then I can run BGP over top of that. I hope that's kind of those pieces are starting to come together in your mind. So 1/25, the IP address is that. MTU, I'll just say inherit, I don't get fancy there, and I'll say save. Turn on BGP peering.
By the way,
I need a router ID.
By the way, Joe,
see,
yeah, just a note, when you do inherit, what is going to be configured is the value 9150 on the interface of the spine face. Yes, because sometimes when they may find the configuration example for IPN and ISN where they see this magic 9150 value. The reason is because by default, unless you change it, the MTU of the spine interface connecting to the IPN or ISN is 9150 byte.
9150. Okay,
just
good to know.
Yeah.
Thank you, Max. Thank you. Okay, last piece of information we need is a router ID. Well, we've never configured anything here on site number 2 before, so we need to go back to our cheat sheet. And this is the one that I picked, 3.1111111. I'll paste that here. I don't need this to be a route reflector. This button here is if you had like more than just 2 sites, you started to scale 3, 4, 5 sites, and you don't want a full mesh BGP peering between all your spines, but you'd rather do sort of route reflector and only anoint a couple of your more powerful spines to be route reflectors. That's what you would use it here for. But I only have 2 sites, so I have a full mesh by default, right? So I don't need this radio button or this little slider on. Okay, that's it, done. I'm ready to actually deploy. And that's another thing about MSO is you create policy first, and then you commit it by deploying it, right? So I haven't deployed it yet, but I'll go ahead and click deploy. Now, what's happening in the background is it's going out and it's actually talking to these APICs and these different sites and saying, hey, here's some configuration for you. Please make it happen. So just so that we know what we're looking at here, what I just configured was this here, right? This link between the spine, and in this case, the IPN is also the ISN. It's just the name, right? You would obviously have, your own set of devices for intending this, but it's just a lab, so you get the idea, right? But the ISN and the IPN can be the exact same network. There's nothing that says no about that. So yeah, I did click deploy, right? So that's good. We got a green message. Everything is looking okay. How do I know for sure? Well, let's come out of the infra config. And if you look, well, visually speaking, there is now a green line between my 2 sites. That's one good sign. If it's red, it means something's wrong. If it's green, it's good. But if you click on the list view or the table view, you can see all the information, or at least the summary of what we just configured, my 2 different sites. The controller states are up. Connectivity is up, right? If there was something wrong, you would see these arrows pointing down and they would be red. And if you hovered over them, it would try to tell you what's wrong, what's missing. But everything is looking good, and this is exactly what we want to see. And again, we're seeing information about localized faults and things, which, again, would want to deal with, but these have nothing to do with multi-site. It's just pulling it in from APIC. We can see our BGP settings. We can see all of the choices we made about multicast overlay TEPs and stuff like that. So we're in good shape. So remember I said that MSO is fundamentally doing two things for me. One of them is acting as a central policy repository for all of my sites. And number two is it's setting up an easy data center interconnect. Well, we just did the number two. That didn't sound right. We just did step number two with MSO setting up the data center interconnect. So I'm going to stop sharing now and pass back over to Max for talking about the other thing, the sort of policy repository, which is MSO's primary role. So let me stop sharing, Max, pass the ball back to you. And a short lecture, and then we'll come back and we'll configure it in MSO.
Exactly. So I want to try to keep this short, guys, because really what I want is to give time to Joe. But I want to clarify a couple of things. So what you have seen so far is the multi-site orchestrator has been used to onboard the sites and ensure that they could join the multi-site domain, where join the multi-site domain means establishing EVPN connectivity spine to spine in a full mesh fashion, which is the default, right? I have several questions about route reflector. You don't need to configure route reflector for these site-to-site EVPN sessions. Just leave the full mesh. I mean, BGP is the protocol of the internet, right? It can deal with the spines deployed across 2 or 3 or 4 or even 12 sites, okay? So leave the default, we establish the VPN peering, and at that point also the VXLAN data plane is empty. But at this point, still there is no connectivity, right? Why? Because in order to establish and have traffic start flowing between fabrics, we need to tell through MSO to the different epic domain, this is the connectivity that we want to achieve. This is my intent, right? And so I need to deploy what we call them like tenant policies. Tenant policies in terms of EPG, bridge domain, contract between EPGs that dictate what type of connectivity and policy I want to establish between endpoints that are connected between different fabrics, okay? And when we talk about defining policies, tenant policy on MSO, we have created for you a hierarchical way of doing that in virtue of the use of schemas and templates. And now, stay with me, don't get confused. The schema is just a container of policy, okay? The schema is like a drawer where you put your socks in your bedroom, right? Where the socks are the templates, which basically contain the specific policies, EPGs, BD, and BRF, right? So the schema is not associated to a tenant, is not associated to a site, it's just a container. Inside the schema, we have the template. Now, it's always the template which is associated one-to-one with a tenant, okay? Each template is associated to a tenant. Inside the same schema, I could have templates all for the same tenant, which is usually what I recommend, so that the schema becomes your tenant schema, right? And you can name it accordingly. But if you wanted, you could have inside the same schema templates that are mapped to different tenants, right? Nobody prevents you from doing that. It's just a hierarchical way of organizing the policy. Now, when you define the template, you map it to the tenant, then you go inside the template and you define EPGs, BDs, contracts. Here you see, I want to define my policy, which is EP1 EPG talks to EP2 EPG with this contract. Then what I need to do at this point, nothing has happened yet from an ACI leaf and spine perspective. Why? Because I defined my policy on the multi-site orchestrator. This is my intent. I haven't pushed it, deployed it yet anywhere, right? So what I need to do next is to basically say, okay, this template, site one template, is associated to my fabric site one. The moment I do that, I then get the opportunity from MSO to push the policy to the epic domain that manage site one, the site one fabric. And when I do that, basically making REST API calls from MSO to the epic will render that policy into that fabric the same way that it will do if you were to configure the policy from the epic GUI or if you were going to configure the policy from an orchestrator, right? We do REST API call the exact same way. That's my point, okay? But when you do that, the site one template basically allows you to define policies. When you make a change to that policy, you can push that change specifically to the single site one where that template is associated, okay? So the template is your change domain, right? Every change you make in that template will then be deployed when you hit deploy to the site where that template is associated. Now, what if I want to create objects that are extended across the sites? For example, VRF. A VRF must exist very often in two sites if I want EPGs for that VRF to talk to each other, right? Or a bridge domain, I want to extend a subnet between my two sites. Well, it means the bridge domain that is associated with a subnet, it needs to be a stretch object between the sites. Then I need to create a template which I can call the stretch template, map it to the tenant, in this case the same tenant one, and then associate that stretch template to two sites, because I want the objects that are defined in that stretch template, a BD, a VRF, or a contract, to be created to both site one and site two. But when I do that, when I push deploy, and this is the important point, that policy, that configuration is pushed at the same time to the ethic domain 1 and to the ethic domain 2, because I need to create the same object in both sides, okay? That means that when I make a change to that stretch template, that change is pushed all the time at the same time to both site 1 and site 2. That's why the template is the atomic unit of change for these policies, okay? I hope this behavior is clear. You will see it in action, right? But as a rule of thumb, inside the schema, normally you should put all the templates that belong to a tenant, so that becomes your schema tenant, your tenant schema if you want. And then you can create templates that are local to each site for locally defined objects, so EPG, BDs that only exist in a fabric, and a template for objects that are stretched across the sites. And you can go as flexible as you want. As I said, you could have templates for different tenants containing the same schema and reference object across templates in the same schema or across schemas. You have no restriction from that point of view. The only thing that you need to keep in mind, as I was mentioning to a gentleman that asked the question earlier, is there is a limit on the number of objects or policies that you can define inside a schema. The limit is 1,000 objects from the MSO release 223. So if you have too much configuration, right, that you need in a given schema, then you need to start creating a separate schema, right? Because there is a counter of objects. When you reach the 1,000, you need to start using a different schema. That's the only consideration, but you can reference objects across templates and across schemas as much as you want, okay? And as I said, in an example where I have 3 fabrics, normally you will have in the schema for tenant 1, in this example, you see all my templates are mapped to the same tenant 1, and I will have a site local template which is associated to site 1, one for site 2, one for site 3. These, I use it for my EPGs and BDs that only exist in that site, right? Subnet that are only locally existing. And I can obviously create contracts between EPGs that exist in site 1 and site 2 and establish routed EPG connectivity between the sites. And then I have a template, which is the stretch template, which is mapped to all 3 sites that I use to define objects that need to exist across all the sites. The VRF is the typical example. I can have BDs, BD1 and BD2 only in site 1, BD3 and BD4 only in site 2, but they are all part of the same routing domain of the same VRF. So the VRF needs to exist across all the sites. That's why is deployed in a template which is associated to multiple sites at once, right? So this is a typical, I've seen customers doing pretty much everything and the opposite of everything, right? But as a minimum, you should keep in mind this utilization of the template as a way to narrow the deployment of policies to a single site or across multiple sites. Last point, you can use multi-site in a greenfield environment, right? Which means you onboard, like Joe did, fabrics into the multi-site orchestrator, and then you start creating a brand new tenant, and you define policies that are stretch policies and site local policies for this brand new tenant, and you push them to both sides, right? From the point of view of this new tenant, these are greenfield epic. I may have other tenants defined there, but I may not care because I'm just using MSO to define policies for this new tenant, right? As long as it doesn't need to connect to endpoints in the other tenants, I can just keep only this tenant on MSO, right? Which is a very important point that you need to keep in mind. Every time you want to use the VXLAN data plane for communication across sites, you need to manage the policy that allows that communication to happen, and the policy could be stretching an EPG or creating a contract between non-stretch EPG from MSO. And there is a technical reason why that is the case. So you cannot configure things in Epic Domain 1, Epic Domain 2 at the Epic level and expect VXLAN to be used between the sites. That will not work, okay? So every time you want to establish inter-site connectivity, you need to manage the policies through MSO, okay? And this is, again, is an example of a greenfield deployment where I create brand new policies for a brand new tenant from MSO, and I push it to the Epic. However, I may also have a scenario where I already have, which is our case that you will see in the lab, which is a realistic use case. I already have a tenant that I've deployed first in my single pod, then extended in my multi-pod, which is what Joe did. And now I want that tenant actually to extend connectivity also and policy to a second fabric, okay? And so in this case, what I can do, I can actually import the policy. I can import the tenant and deploy the tenant also to the second fabric, and I can import policies for the tenant into MSO from the Epic domain where the tenant is already being configured. MSO will allow you to arrange these policies that you bring in from Site 1 into objects that can be in a template that needs to be mapped also to Site 2. For example, if I know that I have in Site 1 a bridge domain that I want to extend and stretch across sites, well, I will import that bridge domain into my stretch template because it's an object that needs to be provisioned also to Site 2, right? And I will have some other object that I bring in from Site 1, and I map it instead to the blue template, which is only associated to Site 1, because these remain local site object, right? So this import shows you all the objects for the tenant, and then you organize them based on the fact in different templates, based on the fact that they are site local or object that you want to extend, okay? And then you can create new policies, the orange, for Site 2, like BDs and EPG that are new, that need to be deployed in Site 2, and then you push the configuration down. And from the moment on, the entire configuration of the tenant with all these EPGs, BDs, will be fully managed from MSO. And Joe will show you how you have actually a visual representation of the fact that this object are now, and this tenant is now managed from MSO and not anymore only from Epic, okay? With this, let's move to the meet. So you have probably 40, 45 minutes, Joe, to show us all the goodness of multi-site in action.
Thank you, Max. Pass me the ball, please. So while that's happening, see, I wanted to do the greenfield example because it's the easiest, but Max twisted my arm and says, no, you have to do the brownfield and import because that's probably what customers would do. And he's right. So I decided to go a little bit more risky and do that. So before I get started, if we run out of time or something goes wrong, right? Because I'm not infallible. There's a link here on Cisco.com where Max and I recorded with Chris a series of 10 modules all around multi-site. And there's the link up there. Sorry, I can put it in the Q&A, copy and paste it. But if you scroll to the bottom, you'll see that there's a multi-site orchestrator thing. So Max does a lecture, I do a lab. Max does a short lecture, I do a short lab. We broke it out into modules, and it shows really most of what you could do with multi-site, things that we don't have time to show today. But I just wanted to let you know that it's out there. So if you have a real interest in multi-site and you want to go deeper, we've done all of this work, and of course the consistency is there because Max and I did the recording. So it's like you haven't even left the WebEx today. So anyways, it's on Cisco.com. I think they have it on YouTube as well. But if somebody asks that question, I'll paste it in the Q&A. No one's asked the question, so I can't paste it yet. So yes, please paste it. Thank you, Jerome. Here it is. This is the link. Good. Okay. Yeah, Vicky, I'll do that too, just in case someone sees yours first. Thank you. Okay, let's get on with it then. So we don't need this anymore. Here we are back in MSO. Let me go back to my slides here so we know what we're working with. So all of the lecture that Max just gave you about templates and schemas, you know what that is? I mean, I'm a simple guy, right? I try to boil things down to like something that my feeble brain can get wrapped around and understand. Remember yesterday when we did all of the tenant level configs, so tenants, VRFs, bridge domains, EPGs in APIC? We did all that in APIC. Well, now that we have multiple APICs, we need a different way to be organized and do that same job. In this case, we're just going to, templates and schemas are basically just the workspace where we do that very same tenant level stuff, just in MSO instead of APIC. So if you don't get lost in all of the details of the templates and schemas, it's just tenant level policy done in MSO, and we'll push it out to the sites that we need. So what am I going to show you now? So you remember yesterday we had created tenant Acme, and we created a VRF V1, and we created some EPGs and some BDs. I think we created BDA. Sorry, we created BDA and we created EPG silver and gold, and some contracts and filters. So let's just sort of ignore the right half and only look at the left of the screen. That's what we did yesterday, and all of that lives in site 1, Amsterdam. Well, we're gonna keep using that tenant. And what I want to do, at least my goal here or my challenge to myself, is I want to take that tenant Acme and I want to stretch that tenant to live simultaneously in both sites. Not only that, I want to take that VRF, the same VRF v1, and have it live equally in both sites at the same time. So I am stretching that VRF between sites, right? That's perfectly within the capability of MSO, you know? So the other thing I want to do is, if you remember, I had created bridge domain B when I did multipod an hour ago, and I created an EPG called servers. Well, now I have a requirement. My business entity has come to me and said, you know, we have the second site in Barcelona. I want to stretch the bridge domain B and the EPG servers that's associated with it. I want it to be stretched across both sites equally. In fact, I want there to be layer 2 adjacency between these two sites in EPG servers, right? So I'm going to actually configure that for you, right, and show you how we do that. Furthermore, I am going to create some additional policy that has never existed before, because you see BDA on the left with EPG, silver, and gold. Those already exist, and I'm going to import those. But bridge domain, I'm going to create a new bridge domain and a new EPG that only lives in Barcelona. So this is brand new. And what I'm going to do is I'm going to make sure that everybody can talk, whether it's routed or layer 2, switched, adjacent. I'm going to make it all talk, right? Then, if we have time, and I hope we do, I'm going to configure layer 3 outs, one in each site. So each site will have its own local layer 3 out. But I want to show you a feature that says if one layer 3 out should fail or go offline, we can actually ride the intersite network and use the other site's layer 3 out in a dynamic fashion. It's all nicely done. If I'm hoping we have time. So with that being said, this is quite a bit to configure. So buckle in. I'm rolling up my sleeves. You can't see me, but I'm rolling up my sleeves, and let's get in. So here we are back in MSO. Let's build what I just talked about in the slide. So where do I go? First of all, under application management. Actually, no, what I need to do first is I have tenant Acme, right? If I go under infrastructure sites, right, we know right now that tenant Acme doesn't live in site Barcelona. Notice that MSO kindly put a little tag in the top of the screen. But if I go to APIC in Amsterdam and I go to tenants, there's my tenant Acme with all the config. First thing I need to do is tell MSO, hey, listen, I want to import tenant Acme, because right now if I go to tenants, there is no Acme. So I need to bring him in. So in site Amsterdam, clicking on the little 3 dots at the right, import tenants. It knows that Acme exists, so I just have to pick it, and that's all I need to do there. So now if I go to tenants, there he is, there's Acme right there. If I click on the little dots to the right and say edit, we see now that Acme only lives in Amsterdam. But remember, I actually want tenant Acme to live in both simultaneously. So I'm just going to say, hey, live in Barcelona too. It's the same tenant stretched across both sites. I'll click save, and that's as easy as that. So I've got the tenant now in MSO, and now let's start building our schemas and our templates. So clicking on application management schemas, I don't have any schema because it's a new deployment. So I need to add my first one. So we'll do that, and we'll call this Acme, and we'll say add. Now this is the workspace that I have to create templates under the schema Acme. So schema is like the top level organizational object, and I can have any number of, well, up to a maximum number of templates underneath it. You know, read the scale guide, and you can't have like 9,999, but you can have many templates underneath a schema, right? So that's what I'm going to do. I'm going to create 3 templates today. So the first template I'm going to do is I'm going to create a template, and by clicking the plus button, and I'm going to give it a name because template 1 doesn't tell me anything. And I'm going to call it common items. It's just the name that I picked for this. So here I have this template common items. The first thing I need to do is say, okay, what tenant are we working with here? Because there might be multiple tenants in play, and we need to know which one. So over here on the right, click on the list. There's my tenant Acme. I'm good so far. So now I have in Amsterdam, Acme already has configuration. You know, we have a VRF, we have bridge domains and blah, blah, blah. I don't want to recreate those. I want to import them. So here in my common items template, there is an import button, and it's going to ask me, which site are we importing from? Well, we know that there's really only one choice there. It's Amsterdam. So this brings up the import window. So what do I want to bring over? So the question is, really, what do I want to equally exist in both sites at the same time? So let's go back to my slide, and remember, I want the VRF. Some contracts and filters would be useful. Bridge domain B and EPG servers. Those are the things that live equally in both sides. That's why I call it common items, right? So let's go back in here and sort of try to map that to the window. So I want the VRF. So I'm going to say, yes, VRF, right? I believe I want not both bridge domains. Well, not in this template. I only want bridge domain B. Notice when I click bridge domain B on the right, there's this import relations. This is basically saying, I know that according to APIC in Amsterdam, bridge domain B is mapped to VRF1. So do you want me to keep that association? And in this case, yes, I do, because it needs a VRF, right? Otherwise, I'd have to make one. So I've got the VRF, I've got the bridge domain. I want to add contracts and filters. Now watch, when I click my contract, allow some traffic, and I include import relations, it automatically picked up the filter as well. So I didn't have to do that manually, right? The other thing I want is, if you remember, I have a bridge domain, no, I'm sorry, an EPG. I don't want to stretch silver and gold, so I'm going to leave those guys alone. But I do want to stretch the EPG called servers, right? And again, relations here. So it's telling me here that there's a contract that's not found in multi-site. So I'm going to have to go and put a new contract here, because right now I think I'm using common default, which this template isn't aware of, but that's okay. I can fix that. But just note that MSO tries to be helpful to say it's not a showstopper, but there's something that you're probably going to have to tighten up or fix to get this all done the way you want. The application profile, of course, the application profile is what's holding the EPG, so that, of course, will come in. In fact, I cannot deselect it. I think that's good, Max. I'm not missing. I don't want the layer 3 out yet, and I don't want the external EPG yet. I'll bring that later, okay? I want to keep it simple.
Yeah.
Okay.
Yeah.
So I'm just going to say import, and there we go. That was easy, right? I mean, we knew it was there. There's my EPG servers, my contracts, my VRF, my bridge domain B only, and some filters. That's really all I need. So what have I done? The blue stuff and the purple stuff I just imported, right? So in common items. So let's just kind of stick with that and say, what's your first challenge, Joe? Well, I want to get an endpoint that lives in site 1 to talk to an endpoint that lives in site 2 over this layer 2 extended bridge domain and EPG. So let's do that part first, and then we'll come back and we'll add the rest. So,
and Joe,
Yes, sir.
Just to comment, right? The fact that you imported here you haven't pushed it back yet, right? And
yes.
so you can show them if you go on Epic, the objects still look like they were before you imported it. So this was Epic 1, right? Or 2.
Okay. Yes.
Yeah. See, you have the VRF. You don't have any specific symbol that tells you that these objects are managed.
Not yet.
That's
not
an important.
No.
Yeah, exactly. I just wanted to point that out. Okay. Go ahead.
Yeah, very good. What he's saying is I've only imported the policy, but I haven't pushed any policy back to sort of allow MSO to claim ownership now of this tenant and these objects. So the first thing I need to do is I need to tell, all I have is policy right now. I need to tell MSO where I want this policy to be pushed. So if I click on the little dots, one of the options, the only option is add sites. We can see it, well, it's already existing in Amsterdam because that's where we imported it from. But I also want this to get pushed to Barcelona. So it's important that I select that and say save. Notice down here, under the sites kind of sub-column, we have Amsterdam and common items, Barcelona common items. Why is it there twice? Well, we call that site-specific settings. There are things that are going to be common, but there might be things like VMM domains as an example, right? I have a different DVS for site 1 and another wholly separate independent DVS for site 2. They are two different things. One lives in Amsterdam, one lives in Barcelona. So we need a way to, let's say, identify site-specific settings and let MSO know about them. That's why you see it like this. So we'll sort of see this expand as we go on. We also see a little yellow sort of icon that says, hey, changes in the template have not been deployed to the site, right? How do we deploy? Well, over here on the right, actually, a lot of times I like to click save and just kind of, there's an auto save, but for me, I just like to commit my work. But really the button I want to press is deploy to sites. So when I click deploy, I get a summary. It hasn't deployed yet, but this is saying, look, here's what I'm about to do. I'm about to write changes. And what am I writing? In Amsterdam, I'm going to do these EPGs, bridge domains, VRS filters, and contracts in Amsterdam and Barcelona. Now it says created, but what it's really doing for Amsterdam is claiming ownership by rewriting the exact same thing and saying now it's owned by multi-site orchestrator. And then in Barcelona, it will actually create them because nothing exists in Barcelona. So we'll click deploy. And yeah, everything.
Sorry, Joe, because there was a question before. This is non-disruptive for the policy that are already deployed in Amsterdam, right? We just add an annotation to each object to basically show the little icon that now Joe will highlight, right? So there is no impact to the traffic that is going on in Amsterdam. Okay, I just wanted to point it out because it was asked.
It is not disruptive. That is correct. So now that we've pushed this, you'll notice something. This is the view of Barcelona. You can always tell by looking at the top. And this is the view of Amsterdam. Notice something has now changed in Amsterdam, actually in both sites, is when I'm in the view of tenant Acme, there's a warning up here. Please don't ignore it. It says, hey, listen, this object that you're in was created from MSO. Any configuration changes or updates, do not do it in APIC, do it in MSO from now on for this tenant. And you can tell the objects that it owns because I know it's really hard to see, but I guess if I try to do this and zoom in, you can see a little extra cloud icon there. That means if I click on it, Acme, is this object was created by multi-site orchestrator. If I go down and I look at my VRF now, there's another little icon there that wasn't there before. This is basically saying, again, multi-site was here and now owns this object, right? Owns this object. So let's go back to viewing, actual size. I think I'm already there. Okay, the same thing is true now. If I look over in Barcelona, tenant Acme is there. We can see there's our VRF. We can see there's our application profile. And only one EPG servers because that's the only one that was stretched, right? We can also see our bridge domain, BDB. All that stuff got pushed by MSO, right? We can even check the policy and we can see the network is 4.1/24, right? So very good. Now, let's actually try to connect things. But remember I mentioned this notion of site-specific settings? Let me show you in my vCenter. In my vCenter, we know all about VC_DVS because we created it yesterday and we've been using it. This is exclusive and local only to site number 1, only site number 1. Site number 2 has its own DVS called VC_site2, right? So, nice name. So you can see here, it's just sitting here waiting. And in site number 2, I've got an ESX host already connected. And it's already connected to the fabric and it's just waiting for VMs to be turned on. But I just wanted to point out that I have site 1 DVS, site 2 DVS. They're 2 different DVSs, right? They are site specific. So we need to tell multi-site about that, right? So if I go into Amsterdam site-specific view of common items, and I click on the EPG called servers, and I scroll down, at the bottom is the domain mapping. Remember we talked about mapping domains to establish EPG membership? That's what I'm referring to. And here's VC_DVS already mapped because that was imported, right? If I look at the EPG servers in the view, local view of Barcelona, so I'll click on servers, and I'll scroll down on the right, there is no mapping yet because we've just imported this and pushed it to Barcelona for the very first time. So I need to make that mapping. So just like we did in APIC, except now this is the look and feel of MSO, it's a VMM domain. I can click on the list and it knows what's there. There's only one choice, but it pulled APIC and says, you know, what do you got for me? On deployment immediacy, I'll just go immediate because, you know, it's a demo, but you have some on-demand choices. And I will click save, right? That is a site-specific setting that's only for Barcelona. Now you can see the icon went yellow because we haven't pushed the change yet. We've only changed the policy here. And now in just a minute, we're going to push that policy, yes? So the other thing, do I need anything else? I think when I was playing with it, Max, I think I needed to go into the bridge domain. And remember how I said I need to stretch this bridge domain at layer 2? So at the top level common items, because this lives equally in both at the same time, I'm going to click layer 2 stretch. No, there is a warning because I screwed up when I was practicing this for you and I almost like had a heart attack. Any existing local site BD subnets will be removed, right? There is a local BD subnet right now from the import in Amsterdam. I'll need to put that back. And that there'll be some other settings change, are you sure? So this is a tiny bit disruptive in this particular example. So I'm going to say yes.
Well, let me clarify your comment. Sorry, disruptive in the sense that is removed
won't be.
and
you're
put
right.
Back. Not at the epic level. Epic level, there is no disruption.
Right.
Nothing is removed from the epic. Okay.
Yeah, you're right. It won't interrupt traffic, but what I did when I was practicing is I deployed without reestablishing the policy here first, and I shot myself in the foot. So that's what I was referring to.
That's why we added the warning. Exactly. That's why we added the warning, because you need to be careful. If you do what Joe did, then you remove the subnet from site 1, and that will create an outage. Absolutely.
Yes.
Absolutely.
So here, if you remember, there's a slide that Max has that shows you like 3 different deployment options for a bridge domain: routed, stretched, or stretched with broadcast, unknown, unicast, and multicast or bum traffic. What you see here is option number 3. I don't want that. I only want layer 2 stretch, but I don't want to flood traffic. So I'm going to disable that button, the intersite bum traffic. I'm going to turn it off, right? But I still need layer 2 stretch, layer 2 adjacency. We can do that without the need to flood broadcast traffic, right? Or unknown unicast. So I'm going to make sure that that's configured. Still in the bridge domain, what I'm referring to is the subnet here of 192.168.4.1 is not here in the policy yet. I haven't deployed yet, so nothing's changed in APIC. But if I deploy without putting the subnet back here, I will shoot myself in the foot. And I did shoot myself in the foot when I was practicing this for you guys. So we'll add that back and we'll say save. So we're stretching this subnet across both sites. So I think we're ready to deploy to sites. Yes, Max, I don't think we're missing anything here.
Should be good. I was responding to questions, but should be good. Yes.
Okay, so you can see we need to deploy to both sites. So we'll click deploy. We're going to modify in Amsterdam, modify in Barcelona, and off we go. So successfully deployed. So we're good, no errors. So let's do a quick test. So going back into vSphere, right, you can see there's my port group of servers. There's my port group in Amsterdam, same port group of servers, but stretched across both sites. Let's actually make it practical and connect a couple of VMs here. So I'm going to connect a couple of Ubuntu Linux machines for a variety. We've been looking at Windows so far. So notice Acme EPG servers in the distributed switch DVS. We know that belongs in Amsterdam, so we'll make that setting. This other virtual machine lives in site number 2, right? It's a different DVS, a different site, a different APIC. So we're going to go in and change its settings to pick the port group of servers, but notice it's in the DVS that's running in site 2, right? But it's the same EPG in terms of multi-site and APIC, right? So now let's go ahead and open up the remote consoles of both of those devices so we can make sure that they can talk across sites. Now this is a layer 2 adjacent thing. So if I look at the IP address of this guy or girl, he's 4.10, yes. And I don't know why he's taking so long, but while we're waiting, let's go ahead and ping our default gateway, make sure that we're connected. And we are connected, so that's good, right? So we know that the default gateway is accessible. That's always a good check. If I look at the guy or the girl on the right, let's check the address here. Let's stop that ping. He or she is 4.30, right? Same network, but in a different site. So we stretch this network. I haven't said that 1,000 times. And let's ping, and we can see, yes, everything is pinging to the default gateway. Now, the question is can 4.30 ping 4.10 or vice versa, right? Well, let's give it a test, right? 4.10. So one on the right is pinging the one on the left. And it's working. Wow. Very good. Let's just do it in both ways because,
Don't sound surprised, man. Don't sound surprised.
No, I know. Don't sound surprised. What I've just shown here is I have an endpoint over here on the left in Amsterdam and an endpoint over here on the right in Barcelona on the same subnet, in the same BD, in the same VRF, in the same EPG stretched. It works. Lovely, right? Now, let's quickly move to the next example, right? I want to import BDA and EPG silver and gold. These are only supposed to live in Amsterdam, but they're going to use the stretched VRF. That's no problem. But the BD and the EPG are specific to site Amsterdam. Then, since we're at it, I'm going to create a brand new BD and a brand new EPG that never before existed, but it only will live in Barcelona. And then I'll get those two to talk, right? So the routed example, the use case number 1 in Max's slide of the BD deployment options. So let's go back to MSO and let's say, how are we going to do that? Well, common items template is really a template for things that are stretched. I don't want that. I want specific to a site. So I'm going to create a new template. And I'm going to call this one AMS only. Yes. And just like before, we want to say which tenant are we working with here. In this case, Acme. We're good. Import just before. So from Amsterdam, I am going to import. I don't need to import the VRF because it's already existed, but I do need to import the bridge domain. So BDA. Now, what's this little error? It says, hey, VRF v1 already exists in the template, so I'm not going to import it again. So even if I wanted to, I cannot import the relation because it will try to re-import the VRF, and we don't need that. It knows, hey, I already have it. I don't need to do the work twice. Right? That's perfectly fine. So then I got the BD. I've got the EPG. I want to bring in silver and gold. And again, we know that the contract and filter that's running here is already imported, so we don't need to do that again. And the application profile, which is the only one I have, is going to come with the EPGs. The contract I don't need because I think it says it already exists, so I don't need to import it. And the filter as well. I think we're good for that. So I will click import. Now again, I haven't attached this to any sites yet. Well, it was already imported, so but I only wanted to run in Amsterdam, so I don't need to make any changes here. What I do need to do is push it back to APIC and claim ownership is really what I'm doing. It's not going to disrupt anything. It's just going to claim ownership and mark the little icon that says this is now an MSO object. So we'll go ahead and we'll click the deploy. So that was pretty easy, right? In fact, if I go in, you can see like my contract association is there, my bridge domain is there, all of the stuff that I needed is how it was when I built this stuff yesterday, right? So it's pretty easy. Gold and silver are there. Now, if that's already saved. I don't need to push anything. So the next thing I want to do is I want to create a Barcelona-specific set of bridge domains and EPGs. Well, AMS only isn't going to do it. Common items isn't going to do it. Let's create a third template, and we'll say these are the items in this template that live only in Barcelona. And just like before, working with tenant Acme, there's nothing to import because these are brand new, right? So what does that look like? So first thing I'll do is I'll attach this to a site, Barcelona, just to make that association. You see it shows up here. And then I'm going to say, well, I don't need a VRF because that's stretched, but I do need a bridge domain. So what did I say I was going to call this? BDBCN. So BD-BCN. Which VRF? V1, because that's the stretch VRF. I don't want any layer 2 stretch here, so I'm going to untick the box, right? And which makes it a purely routed bridge domain that exists only in this site, but we can route to the other site when we need to talk. So I've got that setting there. I think I'm good there. So what's the next thing that I need? Well, I need an application profile. So I'm going to create a new application profile. I'll just call it BCN. And underneath that, I'm going to add an EPG, and I'll call this, what do I want to call it? BCN endpoints, right? So I'll just call it BCN EP. How about that? Which bridge domain? Well, here's the list. It's BDBCN. That's the one I just created. I haven't pushed it yet, but it's the policy that I have in MSO for me. Right now, if I go back to the bridge domain, right? And I scroll down, where am I setting the layer 3 network for this bridge domain? Why isn't it showing up here under the bridge domain? Well, look where I'm at. I'm in the top level template and I'm clicking in the bridge domain. I might in the future want to stretch this to other places. So what this is really saying is that's a site specific setting. So I'm going to click under site level BCN, BCN only, and I'll click on the bridge domain there and scroll down and you will see, there it is. Because this subnet only lives in Barcelona, therefore it is a site-specific setting. And let's go ahead and add, what is it? It's 3.1/24, so we'll just copy it. And we'll say save. So we've got there. Now you can see, what is, I don't know why does that go red, Max, here?
Which one?
Oh no, it didn't. I must have clicked on it. Sorry.
This is, by the way, is a new parameter that was introduced in MSO 3.1 that allows you to change if you want the MAC address for the gateway. Right? It was not there in MSO before.
Oh, okay. So in my endpoint, in my EPG, right, I need to map it to a VMM domain, but how come I don't see it under the EP? It's the same kind of thing as the bridge domain. It's a site-specific mapping, so I have to do it down here. So I'm going to click on my EPG, scroll down. There's my mapping for the VMM domain. I'm going to do this really fast because this should be familiar to you a little bit because we've done it a few times. So I've made the mapping for the EPG. I'm going to need some contracts, right? So I think I do contracts up at this level. So contract, I am going to use the contract that I already was existing, and I think I need to make this guy, a consumer. Let's make him a consumer. So I think EPG Gold was the provider. We can go and check that. And I think that's it for this. Trying to think, we can go and check Amsterdam Gold should be, providing the same contract, so they should be able to ping. Right, so let's deploy it, right? You can see that this one is yellow, so BCN template.
Maybe show, before you deploy, show the ping, right? To verify that you are not actually able to communicate until you push the policy, right?
Okay, let's minimize that. Let's go to gold. I think I said gold, right? So ping.
Yep.
Who's the guy I'm going to use? I don't think I set up the. I haven't set up the mapping here yet, so of course ping's not going to work. But I'm trying to think what's the IP I'm going to use. I'm going to use this guy in site 2, right? I'm using 3. Yeah, exactly. That's workable. So I'll use Ubuntu site number 2. I cannot change his port group because it hasn't been pushed yet, but he will be at 3.100. So for sake of what Max is saying, 3.100 minus T, of course it will fail. That's what we expect for now because we haven't pushed it. So we're going to deploy. Done. Now I can go here and I can assign the port group because the port group will have been pushed by that action. And there's Barcelona endpoints right there. We made that mapping. Let's get into the console of that VM. So this guy is in site number 2. And let's just make sure he or she can ping default gateway. So here we are 3.100. So let's ping 3.1. And yes, working, right? Now let's go back over here. Oh, what happened? What you see? Yeah, it started working. So this guy at 1.10 can ping this other guy in a different site at 3.100. How did that work? Well, when we established the contracts between these different EPGs and different sites, that also kicked off in the background a control plane exchange inside the different APICs that are managing each of the sites to say, these two EPGs need to talk to each other. We will take care of all the necessary stuff that needs to happen in the background to make that work. But because you have a contract, which you remember, contracts allow communication, right? That kicked off that sort of control plane exchange, and now we're able to establish connectivity between these different endpoints and different sites, different EPGs, and traffic flows. It's really actually quite nice, right? So that's the routed thing there. So I've completed this picture. I hope I was able to explain it clearly. I have 6 minutes left. Do I show layer 3 outs, Max?
Absolutely. And you can take 5-10 more minutes if the guys want to go. We have the recording, right? But
This
I
is
think
the
we
thing that I
complete.
haven't practiced. Very
That's
good.
why
Okay,
they
so
pay
what
you. That's why we pay you big bucks, man, to run
well,
on this
I don't know if
edge.
that's true, but I could point you towards my boss, and you can negotiate a salary for
I
this. Okay.
will
Anyways, what
support the
I'm going to
increase.
do is
Yes.
I'm going to take the BD called servers, the stretched BD, right? And I did that because I wanna create a layer 3 out, an independent layer 3 out on an independent firewall in each of my sites. So ASA West, which we know already exists, and I just need to import it. I have to create ASA East for this to work. So the one thing that I need to do is right now there is no layer 3 out that lives in APIC number 2. In fact, if we go down to my networking here, there is no layer 3 out in Barcelona, but there is a layer 3 out in Amsterdam, right? The Internet West. So what am I going to do? I don't have time to actually create the layer 3 out, but that's okay because I have automation. I wrote a playbook that will basically push a layer 3 out pre-configured to APIC from Ansible. So I'm going to go ahead and say, I wrote this playbook to ask me which tenant are we talking about here. So it's going to do it by name. So it's got to be tenant Acme. So let's actually type Acme. And now it's going to go and connect to that APIC in site 2, and it's going to create all the objects that it needs. Boom, done. Right? That was power of automation because now look, Barcelona, layer 3 out, good, right? Let's actually go into the firewall and just make sure that my routing adjacency comes up. So show OSPF neighbor. It's down now, but I believe it'll come up in a second. Let's see if we can ping the far side. And we can't. Max, I might have a small problem.
You also have the external EPG deployed by the script?
Yes, but I think I needed to fix it because my script was really being used for something else. Let me go here, and I had a different network, so let me fix that. This is where...
We'll make it work. No worries. No, this needs to be the subnet itself. So
Yeah, 0000/0 because it's the internet, and we'll say submit.
Specification. Yeah.
There we go.
And on the LT out, you have OSPF. We're using OSPF.
Yeah, OSPF.
Okay, let's see.
Normally that works right the first time because it was working earlier. Well, what we will probably want to do here is my bridge domain. Bridge domain B. If I want to map it here, I'm trying to remember, do I map it here or not?
Show me again, sorry.
Let's maybe my playbook didn't take, right? So let's try it again. Everything's green, so I don't think, yeah. If it doesn't work, I'm not gonna belabor people because it was working when I practiced this. Probably something.
Go 1 second to the LT out. Let's do a quick check and see if there is any fault at the LT out level. So this guy is supposed to be east. Do false. No false. Look at the logical node 1 second. The logical interface. So the node is there. The interface. Routed OSPF profile. Okay. Routed interface.
5.5.2.2. Oh, you know what? I was pinging the wrong one. No, it's still not working.
Okay.
5.5.2.2. Oh, I know why. It's total. When I was practicing, I know why. It's total human. It's human error because when I was practicing my failover, this is the one shut down. Yeah. I had it shut down. So total problem exists between keyboard and chair. So let's quickly fix that. I'm like, it was working like 3 hours ago. No shut. Right now. Yeah, that was so show.
Very nice.
OSPF neighbor. It's down, but it'll, there we go. It's full, right? Show route. We can see here. So I think what I need to do here is I need to attach it to the bridge domain and then off I go. Let's do that in MSO real quick. So what am I going to do? I have a layer 3 out in Amsterdam that's locally specific. I have a layer 3 out that's site specific to Barcelona. Let's go ahead and import Amsterdam first. So in the Amsterdam only template, back to our friendly import, let's quickly bring it in, right? So layer 3 out, going to click it. And I'm not going to import an external EPG because I think, Max, I'd like to create a stretched EPG.
Yeah.
Okay. So I'll remove the other one. So I'm just going to import that, right? And you can see
just
my layer 3 out.
Comment. Yeah, the L3 out lifecycle is not managed on MSO. MSO only has the object, right? The creation of logical nodes or logical interface profile is still done at the Epic level today. We are going to bring this workflow into MSO in calendar year 21, in a release in calendar year 21. Okay, but for now, you need to create it like Joe did it, right? Through the GUI, through Ansible, directly to Epic. Okay.
Yeah. So MSO can't create the L3 out; it can only consume it. Is what he's saying. You have to do that in Epic.
Pretty much.
So I'm going to import the Barcelona side of this this layer 3 out. So this one is Internet East, which is representing Barcelona, and we'll say import. We'll save. We can see we need to deploy both to Amsterdam only and BCN only. So let's go ahead and deploy there and deploy again for Barcelona, right? That's good. Max, if I create another external EPG with the same network, is that going to cause a problem? I think I might want to delete it first in Epic here.
Remove. You can delete it at the Epic level or the yes.
Yes, I'm going to create, because right now I have an external EPG that is specific to Amsterdam and a different one for Barcelona. What I want to do is have a single stretched external EPG, right? So what I'm going to do is I'm going to clean up and delete those and recreate them in MSO, right? So I'm kind of I'm doing a little bit of manual something real quick that if I had
We do
planned
fast
better,
because it's a lab, right? Yeah, there is a way to
and
do
I
it
actually
without
use this for other
disruption.
things. So I need that script
Right.
to stay as it is. So anyways, I did that. That's good. What I want to do here is, remember, I want now an external EPG stretched across both sides. So where do you imagine I will do that? Well, I'll do it in common items because that's where my template that's stretched. Let's create an external EPG in VRF v1. Let's call it everything. No, we'll call it outside world. We are going to add a contract here. We'll allow some traffic and we'll make it a provider. And we'll say save, since we're going to need a contract anyway. I could make a new one, but for sake of time. That's really all I need, because I'm going to map the layer 3 outs locally, right, Max?
Correct. Right.
Yeah. So I've got my external EPG. You see it over here, I've got some red. Ooh, required information missing. What's all of that about? So let's click on here. And MSO is trying to be helpful and saying, hey, wait a second. You have an external EPG that lives in both sites, but you have site-specific layer 3 outs themselves. What are you going to do to fix that? Well, we need to just make that mapping. So in Amsterdam, it's Internet West. And in Barcelona, click on it, it's Internet East. Oh, why does it show up twice?
Acme BCN only, Epic Acme. I think it's BCN only the one that you imported. I don't know why.
That might be because of my script.
Cosmetic. Yeah, we'll look into that.
Yeah.
There must be a
Okay,
cosmetic.
so I've satisfied the red angry error warning, right? And I'll go ahead and save that. Now you can see we need to deploy to both. Well, actually, only need to deploy common items. So we'll say deploy to sites. We're going to make an external EPG in both stretched and successfully deployed. Now, let's just make sure that in Amsterdam, BD, or no, I'm sorry, what was it? I have this, I'm using the stretched bridge domain here. So I need to map in Amsterdam. No, I'm sorry, Amsterdam common items. The bridge domain that's stretched, and I've already got that one map, so that's good. Let's go into Barcelona and go here. I don't have it mapped. So let's go ahead and map it, right? We'll say save, right? So right now, let's make this deploy that.
You're saying essentially out of which L3 out you want to send out the bridge domain subnet, okay? Which is stretched, so you want to send it out to both. Right now.
So if I go back to gold, I wonder, I forget how the contract was done here. Can I ping the internet? I think it's actually silver. If you remember yesterday, I think I said silver was the one that I wanted to get to the internet. And so let's test that. No, what am I doing? What am I missing?
Well,
why am I doing silver? Why am I doing silver?
Yeah.
It's the wrong one. It's the stretch one. It's the stretch one.
Exactly.
What am I thinking? This guy. Sorry, this is the stretched E. And I don't think I put the contract there, so let's consume it, right? So my EPG servers, he's providing that. So I'm going to add that same contract really quickly as a consumer just to make it work, right? Obviously, you'd want to think about how you do that, but so now it should. Is the
external EPG providing the contract?
Yes. I believe so. Let's check it. Yes, providing the contract. So I'm going to deploy this to sites. And if we did it right.
Well, do you have the subnet on the external firewall? That's the first thing to check, right? Because we map the BD.
That's right. This is where I went a little bit off piste, where I said it was going to be a little bit of a risk. So
that's okay. If it doesn't, we.
So he's 4.10. Oh, of course I typed it wrong. Yeah, that's
And
working.
this was a stretch goal. Doing this was a stretch goal. Worst case, we
yeah,
stopped
this was
here.
a stretch goal.
And in the training that we posted, right, you guys will find actually not only these, the connectivity to the L3 out, but also the service integration, a bunch of labs that we did with Joe that will give you, all additional information on multi-site, right? So this was just to show it to you live. But
you know what, Max? Look, I didn't do my subnet classification.
Yeah, I was going to say that, right? So basically the traffic coming in is not classified in the external EPG. Yeah, very good.
Let's do that again. And, not that one. Yeah. See,
and now you ping.
I need Max to help me because I know how this works, but I get flustered when I know it's not like perfectly smooth, right?
I had your boss on the phone, so okay, I can hang up with him and tell him that.
And this is
okay. Good.
This is the guy this one that I'm showing you on the right. This one lives in site 2. He is using Internet East. She on site number 1 is using Internet West, right? So they're each using their local egress to the internet, right? Now we have some challenges because these are firewalls and these firewalls are stateful, right? How do I guarantee that an endpoint in site number 2, which will go out ASA East, won't come back through ASA West, which has no state, which will then drop the traffic. So I'll break the flow. I don't want that. So one of the ways you can do it, and we support it in MSO, is to turn on host routing. So if we look at the firewalls first here, and I show routes, you can see I'm just learning about the subnets, right? So if I go here and show route, you can see I'm learning the same subnet in both firewalls. How is routing going to work? Well, 50-50 chance, right? So what I want to do here is I want to turn on host routing. So I'm going to go, is it at the top level?
At the site level.
At the site level,
because,
okay.
Yeah.
So Amsterdam BDB, I am going to, yeah, there it is right there, host route. So I'm going to say host route and say save. And I'm going to do the same thing for Barcelona, same bridge domain, but this is this site-specific.
And just to comment, it's done at the site level because it allows you to play. You may decide to announce host route only from a remote site and only the /24 to a local site.
Yeah,
you can do
it's flexible,
different
right.
type of things, right? It's flexible.
Okay.
So in this case, we send host route out of both, so you will see what happens.
I'm going to push that change, so modifying the bridge domain in both sites. And if I go back to the firewall, here, east, you notice there, right there, I learned the /32 host route. So 4.30 should use firewall east. This is firewall west. If I do the same thing, is you can see I learned 2 because remember I had a couple of different endpoints there. So I learned host route for any endpoints here in this network. So that way I can guarantee inbound and outbound traffic through the same firewall. Now, if you want to stay for 9 more minutes, I want to show you one last thing and then we're done. So if you have to drop, I completely understand. You can see this video after the fact or the one on Cisco.com. But what happens now is, let's say ASA East, right, dies, right? It completely is gone offline. And now everybody in Barcelona is stranded. Is it possible to let ACI multi-site dynamically realize, well, I have another egress to the internet through ASA West, right? So can we do that? And yes, we can. And it's called Layer 3 Intersite Out. Now, it's a very recent feature addition for multi-site. What was it, Max? 424? ACI 424 and MSO 3 or 224 and later, right?
Mm-hmm. Mm-hmm.
So what I'm saying is it's a relatively recent version. So if you're on ACI 2.1 or 2.2, this isn't possible. You have to read the requirement guide. So how do we set that up? It's actually quite easy. So what I'm going to do right now is I'm going to redo the mistake that I had when I first tried to bring up this firewall. And I'm going to basically shut down gig 01 and ASA East, right? Because I want to simulate the failure. So int gig 01 and shut. So right now, if we go over here, we can see this has broken, right? But you're thinking, well, wait a second. Shouldn't routing dynamically realize that there's another route being learned through ASA West that should be shared across sites? Yes, but I need to configure that to happen. That's a policy choice, right? It's not a default choice. We need to say, this is what we would like to happen, because you might not want that to happen for security reasons or whatever. So how do I do that? So I'm going to go back into MSO. I'm going to come out of my template here. I'm going to go back very quickly into the infra configuration. Remember, we did that for data center interconnect, and go back into that configuration window, go into Amsterdam, and go down to the pod level. There was something here that I kind of skipped over when I did infra, and it's called external TEP pools. Well, if we want to do inter-site layer 3 out, so an endpoint in site Barcelona can now use, optionally, a layer 3 out in site Amsterdam. So in order for that to happen, we need these external TEP pools, right? We don't have them, so I'm going to quickly create them for each of my pods. So 101 for pod 1, might as well do it for pod 2 as well, so 102.
And while you do that, Joe, just 2 seconds. The reason why we need this external TEP pool is because for inter-site L3 out, we create a tunnel, a VXLAN tunnel, directly to the border leaf of the remote sites. Now, these border leaf normally have a TEP address, which is taken from the original TEP pool that you configure when you brought up the fabric, but we cannot assume that that original TEP pool is actually routable, unique for that site, right? So we allow the user to assign a new TEP pool to ensure that that tunnel, that traffic can actually be routed toward that destination. Okay, that's essentially in a nutshell, the reason for that external TEP pool.
Right. So let me. I'm going to go into my border leaf inside Amsterdam, and I'm going to show the IP routing table of what that leaf looks like, and you can see here. Right, it's saying I have an OSPF connection to 000/1. Here's the other half, by the way. I did that on purpose, but basically I have routes to the outside world through a directly connected interface, Ethernet 1/19. This is leaf number 3 in site number 1. That's where the firewall is connected. So this is this firewall connecting to leaf number 3 in Amsterdam. If I look at the leaf in site number 2, where I just killed the firewall, and I did that, I have no route yet, but we're going to come back here and take a look after I add my external TEP pools for all of my pods. So this is the TEP pool for Barcelona pod. Save, right? So I've got TEP pools on all of my pods. We need to deploy, right? We need to deploy that, right? So that's good. So I think that part is done, right? Now if we go and we look at the IP route, oh, what happened? Interesting. I learned a route to the outside world from BGP via 192.168.101.226. Well, what is that? And where did that come from? That is the IP address that MSO just handed out to the leaf in Amsterdam, leaf 3 in Amsterdam, from the external TEP pool that I just configured in MSO. So now this is one of the ways we enable the routing. We're not done yet because, as you know, there are some mappings that we need to do. So back into our schema of ACME, we want the bridge domain in Barcelona. Where is he? Where's bridge domain B to also use the internet egress in West. Save, and deploy. And what's happened? The ping started working again. See? Now he can get to the internet because I built that inter-site layer 3 out with the routable taps. Okay? I know I kind of went through that fast, but we did break it down more in the Cisco.com video module as well. So at least I got it working, so I feel good. I can reliably, comfortably say that I did what I promised I would do. So here we are at the end. We now built upon what we did yesterday, fully functional multiple ACI fabrics, plus multi-pod, plus multi-site, and doing all of that from a central repository engine called MSO. there's so much more we could show you. We didn't have time for multi-site. So tomorrow, it won't be Max and I. It'll actually be our colleague Domenico Dastoli, who's even more exciting with the technologies he will show you tomorrow. Namely, how do we integrate containers into ACI as endpoints? We have a nice way of doing that. And then also, how do we extend ACI beyond multi-pod and multi-site? What about the public cloud? What about Amazon? What about Azure? How can we extend this ACI notions of policy and visibility and control to the cloud as well at the same time as my home ACI fabric? Domenico is going to talk about that tomorrow. So I'll close by saying when it comes to multi-site, Max has written a number of really detailed and specific white papers that I find extremely useful. Anything from service insertion to configuring multi-site, what you see here. He's done endless sessions at Cisco Live, and those are free to replay if you want. So those are all included here in this particular slide. And like I said, Max wrote those white papers himself. So I call him the Podfather because he's Italian, but he's also Il Padrino, if you get the joke, Padrino. Anyways, that's it for us. I am going to stop sharing Padrino. And do you want to say any final words, Max, before we end? Thanks for staying late.
We apologize for being 18 minutes late, but hopefully we share valuable information with you. Look at the papers, look at the training, and get back to us if you have specific questions that we can help you with. Thank you for your time.
Thank you. I think we can end the recording or stop the recording, Raffaella.
Those were Max's famous last words.
Which are?
What you just said, because Joe said, do you have any last words?